ahora el profesor Cirac, que es de Lérida y el director del Max Planck, de uno de los departamentos del Max Planck de óptica cuántica de Múnich. Es uno de los grandes físicos no españoles, mundiales, en la frontera. Sus contribuciones son al mismo nivel que los otros que nos han acompañado en esta sesión, porque en este simposium hay premios Nobel y otros del mismo nivel que algún día lo serán o no, y por eso sus contribuciones son igualmente importantes. Uno de ellos es Ignacio Cirac. Para nosotros un placer recibirle. Primero hablará Ignacio, después Frank Wilczek, premio Nobel de Física, y después Jean-Marie Lehn, premio Nobel de Química. Ignacio.
Hola, buenos días. Bueno, en primer lugar, deciros que estoy muy contento de estar aquí entre todos vosotros. Es un gran placer y es una situación que a lo mejor es nueva para vosotros, el estar delante de algunos científicos, pero también es nueva para nosotros, el estar dentro con un conjunto de personas jóvenes que no son científicas. Y lo que me han dicho que al principio os cuente un poco mi vida en 5 o 10 minutos, ¿no? Cómo llegué pues a dedicarme a la investigación. Bueno, como ha dicho Pedro muy bien, yo soy nacido en Cataluña, de padre catalán y de madre navarra. Mi madre es de Lavallen, de un pueblecito que está en la frontera con Guipúzcoa. Y pues desde pequeño pues a mí me gustaba mucho pues lo que os gusta a todos vosotros. Jugaba mucho a fútbol, a tenis, baloncesto, pues no sé, me gustaba jugar ajedrez, leía libros de ciencia ficción, pero la verdad es que nunca había pensado dedicarme a la ciencia. Yo pues en el colegio pues, siempre me hacían algunas pruebas y me decían, no, tú tienes que dedicarte a la ingeniería o a la arquitectura. Pues sí, así que yo, siguiendo los caminos que me habían dictado en el colegio, los que me habían dicho mis padres, pues me fui a ingeniería aeronáutica en Madrid. Y duré 5 días, ¿no? Porque la verdad, lo primero que nos dijeron cuando llegamos a clase es que aquí lo que tenéis que hacer es aprender a resolver problemas. Me da igual que entendáis o que no entendáis de qué se trata, lo importante es que al final el número que dais del resultado correcto. Y es lo único que vamos a mirar en los exámenes. Yo llegaba, soy el profesor de física, llegaba el profesor de química y nos decía algo parecido. Bueno, pues a mí aquello no me gustaba. A mí lo que me gustaba no es llegar al número final, sino el saber cómo llegar a ese número y el entender cómo se podía llegar y entender todo lo que había alrededor. Así que el 6º día fui a físicas y me puse a estudiar físicas, al principio pues, sin saber un poco lo que quería hacer. Me llamaba la atención la investigación, pero no sabía qué es lo que quería hacer. Así que cuando estuve en 3º de físicas, de hecho, pues mis padres me insistieron y me dijeron, físicas, al final, pues no sé lo que vas a poder trabajar, pues, esto de la ciencia es muy difícil, nadie llega. Así que me convencieron para que estudiase ingeniería. Así que me puse a hacer ingeniería a la vez, ¿no? Estaba haciendo físicas e ingeniería, hasta que al final terminé físicas, me empecé a hacer el doctorado, ya dejé lo de ingeniería, que yo no me gustaba, y me dediqué a la investigación. Me fui a Estados Unidos, estuve un par de años en Estados Unidos y me dediqué a trabajar en un tema en concreto, ¿no? Que es la física atómica, la física cuántica dedicada a la física atómica. Eso pues el saber cómo se puede dominar el mundo microscópico de los átomos, pues cómo hacer que los átomos se paren, que los átomos pues se reflejen, que los átomos se comporten como ondas de luz, ¿no? Y en aquella época era un tema de investigación, pues porque se estaban haciendo muchos experimentos y se había podido dar ese paso de llegar al mundo microscópico en el cual esas partículas que los átomos se comportaban como ondas, ¿no? De la misma forma que la luz. Y estuve allí en Estados Unidos, de hecho también trabajando en la Universidad de Castilla-La Mancha, hasta que en el año 94 hubo un congreso en Colorado, en la Universidad de Colorado, donde un señor dio una conferencia en el que nos explicó algo que parecía muy extraño, que era que si uno se tomaba en serio la física cuántica, uno se creía que las partículas pues podían estar en 2 sitios a la vez, desaparecer en un sitio, aparecer en otro, etcétera, etcétera, pues que en principio se podía construir lo que llamaban un ordenador cuántico, un ordenador basado en las leyes de la física cuántica. Utilizando estas propiedades extraordinarias de los átomos se podían hacer cosas extraordinarias. Y eran unos ordenadores que fuesen mucho más potentes que cualquier otro tipo de ordenador. Bueno, por aquel entonces yo no trabajaba en eso, en física cuántica, pero al final de su conferencia este señor dijo, el problema que tenemos es que no sabemos ni cómo construirlo, ni de hecho si se puede construir, porque no conocemos ningún sistema físico que pueda dar lugar en el que se puedan observar estas leyes y utilizar de la manera que lo hace un ordenador cuántico. Bueno, pues yo estaba sentado en esa conferencia conjuntamente con Peter Zoller, que era un colaborador por aquella época, y los dos nos dimos cuenta de que con lo que estábamos trabajando, de la misma forma que intentábamos enfriar, parar átomos, etcétera, etcétera, pues se podían utilizar esas técnicas para construir un ordenador cuántico, al menos en principio. Así que eso fue como empezamos a trabajar en los ordenadores cuánticos. Y, por suerte, al cabo de unos pocos meses, llegó un grupo experimental de allí, de Boulder, y hicieron un experimento en el que demostraron que nuestras ideas realmente podían funcionar. Y ahí empezó un poco el salto, ¿no? Y pues la gente empezó a interesarse un poco más en los ordenadores cuánticos, viendo que eran posibles, aparecieron otras propuestas, otros experimentos, y un poco hasta hoy. Bueno, lo que quiero decir con esto, ya resumiendo, es que y si me hubiesen preguntado a los años, cuando tenía 16 o 17 años, que si algún día me iba a dedicar a los ordenadores cuánticos, en primer lugar, pues por aquella época no había ni ordenadores cuánticos, y eso quiere decir pues que muchas de las cosas que oigáis aquí tal vez no tienen nada que ver si os dedicáis a la investigación con lo que vayáis a hacer luego, porque no existen. Yo cuando estaba estudiando el ESO, pues no existía nada como los ordenadores cuánticos, ni nadie se podía imaginar que existiese algo así. Por otro lado, que al ser científico, bueno, pues algo que en mi caso llegué de una manera más o menos casual, pero porque pensaba realmente que lo que me interesaba era entender cómo eran las cosas, cómo funcionaban y llegar a este punto. Y en tercer lugar, es que cualquiera de vosotros pues puede llegar a estar en un sitio como este dentro de otros 20 años, ¿no? Como me pasó a mí, ¿no? Pues uno tiene que tener un poco de suerte, trabajar mucho, aprender el lenguaje, como ha dicho Pedro, de las matemáticas, de la física, etcétera, para comunicarse con los demás y, bueno, y tener mucho entusiasmo y pasión por lo que hace.
Hello, I'm Frank Wilczek. I'll say a few words about my life and then about my work. My grandparents were born in Europe, in Poland, in what was then the Austro-Hungarian Empire, and in Italy, so I'm a real mongrel. They came over to the United States around the time of World War I. With nothing. They were very poor immigrants, didn't speak English. My parents were born grew up in the Great Depression, so we didn't have, they were not very well educated or very wealthy, as it turned out. But fortunately for me, I grew up in New York City, where there was excellent educational systems, and during the time of the Cold War, which, although it was mostly a bad thing, had some good effects on society in that it directed a lot of resources towards science and education, which I benefited from. I remember very vividly when Sputnik was launched, the sense of urgency and threat that I, even though I was a very small child, that was all around us, and that we really had to focus on science, or that we'd be in terrible trouble. I think now the problems that face us are less tangible, but maybe even more urgent, and really require the attention of society to be focused on scientific and technological issues. Anyway, as a child, I was very interested in magic and learning how to do magic tricks, and also in solving puzzles. But when I actually learned about the magic tricks, I was very disappointed, because they were all cheats. They were all, based on deceit. But on the other hand, there was a television show called Mr. Wizard, Watch Mr. Wizard, where he did magic tricks that seemed completely magic, but that were based on science. One thing would turn into another or change color, or invisible things would cause bits of paper to move and things like this. And this seemed like a kind of magic that really worked. And so I got very, very interested in that. And I was always interested in mathematics. Well, then my life was pretty straightforward. I went from one great university to another, learned mathematics, and my style has always been to look at mathematical theories that relate to the physical world and to look for weaknesses and opportunities, look for things that don't look quite right, don't look quite complete, or where there are ideas that haven't been exploited as much as they could be. Once I was asked to summarize my technique in a few words, and I came up with a description in 3 words that's also infinite, which is think, play, repeat. And that's what I like to do. I like to think about things, then find something that doesn't look quite right, play with it, see if I can make it better, and then start all over again if I succeed. Okay, so over the course of my career, I've done many things, but let me just mention a couple that have been particularly fruitful and have absorbed a good fraction of my attention. There are 4 basic forces of nature, as we understand it currently: gravity, electromagnetism, which are the classical forces, and then 2 that were only discovered in the 20th century that in ordinary life play out mostly within atomic nuclei, so forces that are very hard to study or even know that they're there, that were only discovered in the 20th century. And these are called the strong and weak force. But they're just as fundamental in physics as electromagnetism and gravity. Anyway, what I did was figure out the equations for the strong force. So we have equations sort of as basic as Newton's laws of gravity or Maxwell's equations for electromagnetism for the strong force. And these equations have the remarkable property that they predict that the behavior of this strong force, this most powerful force in nature, which is the force that holds quarks and gluons together into protons and neutrons and holds atomic nuclei together, that the behavior of these forces becomes, instead of more complicated, becomes simpler when you go down to very short distances or when you have very high energies. Or another way of saying it is that the forces become weaker at short distances and stronger at far distances, which is very unusual. The fact that the things become simpler at high energies or short distances opened a lot of doors. Because in the early universe, things were very hot and very dense in the early moments of the Big Bang. That was perfect for this theory because that's the kind of thing we can calculate, and so it opened up the study of the early universe, which has led to remarkable results, understanding the origin of the universe as we see it now as a result of events in the first small fraction of a second in the life of the universe. The fact that the equations for the strong force turn out to be sort of have a family resemblance to the equations for the other force, and also that they change in their power with distance, opens up the possibility of understanding the different forces all as manifestations of one underlying unified field theory. And we've made great progress along those lines. And actually, at the moment is a very exciting situation because the crucial tests of our ideas about unification of forces are finally going to come at this great accelerator, the LHC, the Large Hadron Collider, that's just starting to operate at the CERN laboratory near Geneva. I'll talk about these things in more depth on Wednesday night. Perhaps most important, though, is that understanding the strong force kind of clears the way for fundamental studies of other forces, because when you study interactions at high energy to try to unravel the most basic forces, it's very important to control the strongest forces, to understand them in detail so that you can see smaller, newer effects that are underneath these big dominant effects. So that's the story of most of my work on fundamental physics. In the sense of finding the most basic laws. I've also, in recent years, been very interested in trying to exploit the laws to do something useful. And this relates to what Professor Sirac talked about, quantum computing. The big problem in quantum computing is that the quantum world, which it potentially is vast in its resources, involves spaces of enormous dimension, and so has lots of room for new devices and new kinds of ways of computing, gigantic memories, massive parallel processing. It's just an extraordinary prospect, also solving the equations of quantum mechanics to make new materials. The problem is that the units we would like to construct quantum engineering out of tend to be very delicate. Quantum engineering is the quanta are very, very delicate things, and we're trying to exploit very, very delicate properties. So one thing I've been working on in recent years is trying to make objects that are not so delicate and yet have quantum properties. These are things called anyons, and well, we're getting there. So it's a very exciting process, but we're nowhere near there, so we need help. So thank you.
Okay, good morning. I'm Jean-Marie Laine. I'm filling in for Roald Hoffmann. I'm very happy to do that because Roald Hoffmann, in fact, was my first American friend. When I arrived as postdoc in Cambridge, Massachusetts, there was one young fellow there who just had finished his PhD with Lipscomb. And I was working in another lab, and Roald became my best friend. So I'm happy to be here and to fill in for him. Now, since the other two colleagues have talked a little bit about how things came about, first of all, I would like to say also that the event like this one this morning is something many of us do, and I'm going regularly to high schools in France, and not just in France, also in other countries, because I feel that that's the end of high school is the time where you begin to wake up, usually, about what you are going to do. And I like to talk about science and chemistry in particular. And if at the end of the day, one of you will become a scientist in general, maybe even a chemist, I have made my day. Now, I was born in a small city in Alsace, which is the east of France, which has changed hands quite a few times over the centuries, and which is a sort of a region with two cultures. Of course, we are French, but initially, in the Middle Ages, we were part of the Roman German Empire. So we have a local language. It's not Basque, it's Alsatian. And I think it has the advantage of opening to two cultures. And we are quite proud of that, I must say. Being French, speaking French, my normal language is French. But Alsatian, which I have spoken with my parents, is like Swiss Dutch, like the Swiss Dutch, what they speak in Switzerland, in this German part of Switzerland. So we have also access to the German culture, which is a very important culture in the Central Europe. Many musicians, composers come from there. I love music, so you cannot forget about that region of the world. So what did I do? First of all, I would again publicly thank somebody I owe a lot to, my primary school teacher. He woke me up somewhat. I was a moderate student, and he sort of put fire into us. He spent a lot of time, in addition to his normal hours, just to have the young people, the children from this small city, going to high school. That was the first step. And so I went to high school, and after that, at high school,
Bale, besterik gabe, hasiko gara galdeketarekin. Orduan hasteko, lehenengo zenbakia eman diot biografiari buruzko galderei, hortik aterako dut, galderatxo bat. Eta lehenengo galdera, 77 garrena da, 77 eta ikastetxea, Pasai Lezo liceoa, 77, Pasai Lezo liceoa.
How do you feel by making important contributions to science? What do you like most of researchers' life?
Guztiontzat, pixka bat.
Well, there's a lot to like. Yeah. So there's a lot to like. I guess one thing I like about science is sort of the same thing that people like about solving Sudoku or crossword puzzles. You just have these little puzzles, problems that you can play with and pose, and it's just a joy to figure something out that hasn't been figured out before, even if it's insignificant, as it is in a Sudoku puzzle. But the extra thing in science is that the puzzles you solve have significance, and they kind of build. And you solve one, and it helps you solve the next, and it's a permanent contribution to human knowledge. So that's fun. Another thing that's fun is sometimes you do a piece of work, and then years later, or sometimes only weeks or months later, you or other people realize it had more significance, it meant more than you started with. There's this magic property of the mathematics and the laws of nature that you get out more than you put in sometimes. There's the equations are smarter than we are. And then finally, if you happen to be lucky and hit it big, then you get trips to Stockholm and get to have events like this with young people, and it's really fun. Yeah.
I think I have not much to add. I said quite a few things a moment ago about why I like what I'm doing. The basic thing in science is probably what is written on these people here, passion for knowledge. That's what we have. In your life, you must have passion for something. And it's very important. Even psychologically, people have shown that the state of the brain in a state when you are passionate, and not the brain only, the whole organism, makes you much more amenable to storing information and to thinking if you are passionate. That is something very interesting in terms of the relationship between mind and body. And there seems to be good indications by neuroscientists that the stage in which the organism is when you express passion, which is a molecular stage. Passion depends on what molecules you have in you, in some state. And this is something very important for learning. So passion for knowledge. Maybe one thing I should also add, that knowledge is probably what we are driving to. We have the drive for that. Human curiosity about what we are doing around here was at the beginning of science, of course. And as I will say this evening, but again, since many of you will not be there, the first gesture of a scientist, what was it? The first time science started. That is when Eve took the forbidden fruit, the tree of knowledge. When she took that, science started.
Passion for Eve.
Oh, sure. Vale. Venga, seguimos con la segunda pregunta. Vamos a coger una pregunta sobre ciencia, sobre los trabajos que han hecho estos tres científicos. La número 15, pregunta número 15, realizada por el Colegio Andrés de Urdaneta.
A Frank Wilczek. ¿Cree usted que algún día se dará con una teoría unificadora que lo explique todo en el universo? Hemos oído hablar de la teoría de cuerdas como posible teoría unificadora. ¿Puedes explicarnos en qué consiste y su opinión acerca de la misma?
You want me to translate? Yeah. Okay. What is that? Do you believe that someday it will be found a unified theory that explains everything in the universe? We have here about the theory of strings as a possible unification theory. Can you explain in what it consists and your opinion about it?
I think we've made remarkable progress in understanding basic forces of nature. As I said earlier, in the present state of physics, we understand that there are four basic forces, and there are very concrete ideas for how to unify three of them with each other. That is electromagnetism and the strong and weak forces. The equations for these different forces have a family resemblance one to the other, and they look like they really should be put together. And when you follow out the logic of that suggestion, you find a lot of things click together very, very nicely. So I think nature is giving us some encouragement there. Because of my work on how interactions change in their power with distance, you can actually make quantitative predictions based on unification. That is, if the different forces are going to unify, there have to be certain relationships among their strengths, and those relationships appear to be at least approximately true in nature, and will be very accurately true if there's a supplementation of the physics we know by something called supersymmetry. So that mathematical striving for unification has led to some definite suggestions for new particles that should exist, and that existence will be able to be tested at the LHC. So we're at the point where we can not only dream about unifying the forces, but where that these dreams have taken a very concrete shape and made definite suggestions for experimental tests. Gravity is the other force of nature, and it appears to be rather different in its formulation. The other three, as I said, have a family resemblance. The equations of gravity look like maybe distant relatives, but not quite in the same family. Maybe like the other three are like human beings, and gravity is like chimps or something, a little further removed. However, this unification of forces does also suggest quantitatively that gravity becomes equal in power to the other interactions, so that's encouraging. However, it's by no means so straightforward to make equations that actually put all those four forces on the same footing. It's easy to make equations that put three of them on the same footing, but when you try to include gravity, it gets much more complicated. Now, string theory is an attempt to put gravity together with the other forces. At present, it's still quite vague, so it doesn't lead to concrete predictions. And so if you've heard that it's a theory of everything, you've been misinformed. It's not. It definitely, in fact, it's very curious. People say it's a theory of everything but can't be tested. But if you think about that for a moment, a theory that can't be tested is really not a theory of anything, because anything that it predicts is a way of testing it. So, so it's a theory of everything, but at the same time, not a theory of anything in particular. However, it's not a finished product. It's a work in progress, and so it's still possible that it will lead to more progress in physics, become more definite, and allow a unification of all the forces. However, I want to emphasize, I really hate the whole phrase theory of everything, because it's very misleading. Suppose we did have a unified theory of all these interactions. Would it explain what love is? No, it wouldn't. Would it help chemists? No, it wouldn't help chemists. It wouldn't be. So you can call it a theory of everything, and in some sense it would be a foundational theory for other sciences. But you shouldn't think that the millennium will have arrived, or nirvana, or something, or that anything about everyday life will change if we achieve this unification. It'll be a marvelous intellectual achievement and very beautiful, but yeah, so that's what it'll be. It'll be a work of art, not a practical structure that allows you to explain everything that there is to explain.
Venga, jarraituko dugu beste galdera batekin, orain iritziari buruzko galdera bat, galdera orokor bat, zuek planteatutakoa.
I should also say that we're very far from having a theory of everything.
Vale, urrengo galdera, 53. Instituto Usandizaga, Peña Florida. 53. No. Oye.
Esta es en general. ¿Cree usted que el uso de calculadoras y ordenadores nos hace más vagos? ¿Debería limitarse su uso entre los estudiantes?
Bueno, yo creo que existen varias vertientes a esta pregunta. Los ordenadores, nos abren también la mente, nos hacen ver cosas que de otra forma nos serían posibles, nos hacen ver historias que de otra forma no las podríamos ver. Es una forma distinta que nos ha abierto la tecnología para podernos acercarnos a la vida, y tiene su lado positivo y tiene su lado negativo. Ya hablando más en concreto, no tan forma tan general, te voy a contestar con una experiencia que tengo y que la noto pues todos los días con la gente que está dentro de mi grupo trabajando en investigación, los estudiantes más jóvenes sobre todo. O sea, yo cuando estuve haciendo el doctorado, los ordenadores empezaban a funcionar y los utilizábamos de vez en cuando, pues sobre todo para hacer gráficas, ¿no? Cuando uno tiene un resultado, lo quiere representar para mostrárselo a los demás y los números no te dicen nada, de tal forma que lo haces en términos de unas gráficas y todos vosotros pues aprendéis a leer gráficas. Es una forma muy eficiente de comunicación y los ordenadores lo hacen de una forma muy precisa, muy rápida y muy bien, y aquello lo veía yo muy útil. Con el tiempo, un poco más adelante, yo cuando ya había terminado el doctorado, pues los ordenadores también podían hacer, bueno, ya desde hacía tiempo, pero ya se utilizaba más para hacer cálculos numéricos. En el sentido de que cuando uno tiene unas ecuaciones, pues tenía que hacer un pequeño programa y después de hacer el programa, pues podía obtener los resultados que luego dibujaba dentro, utilizando una función. Y aquello pues ya empezaba a sonar un poco, a hacernos la vida un poco más fácil, ¿no? Hasta entonces pues uno cuando tenía unas ecuaciones tenía que pensar mucho para saber cómo resolverlas, tenía que hacer aproximaciones y bueno, pensar mucho sobre las ecuaciones y bueno, había que pensar un poco menos, pero aún así, bueno, pues uno primero pensaba y si no había otra forma pues utilizaba los cálculos numéricos. Bueno, más adelante salieron programas algebraicos. Es decir, que no solo resolvían esas ecuaciones, sino que te permitían deducir las ecuaciones, ¿no? Tú ponías una serie de ecuaciones y ellos te coge las ecuaciones y te dan el resultado. Por ejemplo, una integral, ¿no? Si habéis estudiado cómo hacer integrales, antes hacía las integrales, había varios métodos y tenía que pensar cada vez que tiene una integral, pues no. Ahora ya era posible que cada vez que te surgía una integral te ibas al ordenador y el ordenador te daba el resultado. Bueno, y hoy en día, pues los estudiantes que tengo, pues cuando les sale una integral o les sale cualquier cosa, una serie, lo primero que hacen es irse al ordenador y yo eso lo veo fatal, terrible. Y de hecho, al fin no consiguen, la mayoría de las veces no consiguen hacer las integrales porque estos programas no son inteligentes, ¿no? Y a veces para hacer estas integrales, o el objetivo no es hacer las integrales, sino el deducir las fórmulas y no plantearlo todo solo como un conjunto de cálculos que hay que hacer. Y eso hace pues que al final, pues uno, cuando sale un problema, al ordenador hacerlo, y quita mucha imaginación, quita mucha creatividad. Y muchas veces incluso no hace las integrales que hay que hacer, no hace los cálculos que hay que hacer. Así que yo aconsejo a mis estudiantes que primero se miren los cálculos que tienen que hacer, que piensen, que deduzcan las ecuaciones, luego miren en tablas y luego, si no existe otra posibilidad, pues que ya utilicen los ordenadores. Así que en este sentido sí que creo que nos está haciendo un poco más vagos. Este es el sentido, es un poco perverso de los ordenadores, aunque también hay otros sentidos más buenos, como que sin los ordenadores pues no podríamos hacer ciertos cálculos, sobre todo numéricos, que hoy hacemos.
Seguimos, vamos a sacar otra del mismo bote. Bueno, esto es una pregunta que...
Espera un momento, porque el profesor Len quiere añadir algo.
Yeah, I want to say something to computers. I think they are fantastic instruments, fantastic tools. And they have developed in parallel with other tools. Big computations, be it for spacecrafts, cannot be done by hand. Big machines like when you go to the hospital and have a scan, MRI, all these things do not exist without computers. They cannot be done without computers because this would be too long. So I think in addition to being a research instrument, they are tools, very, very important tools. And we should not forget that. Of course, it is true that sometimes it's better to think, but you don't want to think about how to interpret a signal coming out from an imaging machine. This is the machinery. The machinery does it. That's not for you. It makes you freer to think and let all the logistics, all the sort of ancillary type of things do by this machine, which does it. So you are freer. You can dream, you can think, you can imagine. The computer doesn't do that.
Vale, urrengo galdera, zoritxarrez, berandu jaso genuen eta ezin izan dugu zerrendan sartu. Orduan, barkatuko didazue, English Schoolek egin zuen, baina zuen zerrendetan ez dago. Orduan, hori barkatu beharko duzue, baina nik irakurri beharkoet. It's a question especially for Professor Echenique, I think. And the question is, what do you think about the quality of science in the Basque Country?
I think it's very good, but I will ask Zirak to answer because he is not part in the judgment. Uno no puede ser juez y parte en esta respuesta. Es mucho mejor de lo que era hace 30 años, mucho peor seguramente que globalmente que lo que es el MIT o Estrasburgo o Gargin. Hay pequeños grupos. So of course, we are always very alert in the frontiers. But I think Zirak should answer this question.
Bueno, yo no conozco muy bien todo el sistema vasco de ciencia, pero conozco bien el instituto de DIPC donde he creado y donde trabaja Pedro, y lo que se puede decir de ese instituto es que está al nivel más alto internacional. Es decir, no es un centro pues en medio de un sitio, es un sitio donde tienes científicos conocidos en el mundo, donde se publican en las mejores revistas del mundo, donde le invitan pues a Pedro y a sus colaboradores a dar conferencias pues en Estados Unidos, en cualquier otro sitio del mundo. Y yo espero que eso sea el reflejo de la ciencia en el País Vasco. De momento existe el de IPC y supongo que habrá otros en otros campos, ¿no? Pero lo bueno sería que hubiese muchos como el de IPC. Bueno, tampoco todos, ¿no? Pero que hubiese 5 o 10 centros de ese estilo. Yo creo que tienen un buen maestro para seguir ir construyendo este tipo de centros.
Como veis, en la ciencia la amistad también es muy importante y yo agradezco a mi amigo Cirac estos comentarios, por otro lado, bien objetivos, pero lo que se trata es con este Congreso, Passion for Knowledge, es precisamente el mayor objetivo del Congreso, es la cantera. El provocar la ilusión por la ciencia, la ilusión por conocer, no solo por la ciencia, y que la sociedad apoye la ciencia, pero sobre todo que los jóvenes encuentren que la ciencia es una actividad, dedicarse a la ciencia es una actividad ilusionante, más que tanto por el carácter utilitario, sobre todo por el carácter cognitivo, y de paso convencer a la sociedad que también merecen ser recompensados. Porque a veces hay un argumento que utilizan los grandes científicos, el día pasado Cirac lo utilizaba, de encima trabajo disfrutando, soy muy afortunado, pero ese argumento que es muy bueno, si se lleva al extremo, puede llevar, como dicen algunos, pues entonces les tratamos un poco peor. Y yo estoy seguro que Rockefeller también disfruta de su trabajo, y estoy seguro que los banqueros, y yo estoy seguro que Messi y Maradona también disfrutan de su trabajo, pero por eso no se contentan con sueldos bajos. Por lo tanto, este Congreso quiere promocionar la cantera, pero también promocionar a la sociedad para que cuando lleguéis a la ciencia estéis tan bien tratados como está Wilczek, Jean-Marie Lehn y Cirac en sus sitios, y esto es algo que nuestra sociedad todavía no ha aprendido.
Venga, seguimos con una pregunta sobre las biografías de los ponentes. Puede ser que algo haya salido ya en sus exposiciones, entonces, bueno, ellos valorarán el interés de dar algún detalle más al respecto. Vamos a ver si la puedo abrir. Sí. Bueno, pues era una pregunta para Hoffman, así que vamos a ver si la podemos trasladar a Jean-Marie. La número 6. Sí, yo creo que sí. Antigua Luberri bigarren hezkuntzako institutua. 6. galdera.
Kimikaria izan da nola sartu zinen poesiaren munduan? Kimikan eta zientzien orokorrean poesiarik bal dago?
I'm not a poet myself. I'm much more interested in music. I play piano and I like music. I think poetry is perhaps, in some ways, playing, let me sort of paraphrase, because Roald would certainly answer that differently for me. But I can see that the playing with the words, the imagination, making connections between words and sounds of words and lengths of sentences. When you read good poetry, there's poetry which is very regular, and there's also what is called versified poetry, textual poetry, like people who don't have verses but have a text but is very poetic. And this has to do with the way words are connected, the way they sound, and also the meaning you can imagine on top of that. And I think in science there's much of that too. The most important thing, I think Einstein said at some time, is imagination. Let things go. Let things tumble around. This is why for scientific research, you can have a good idea anywhere. It's not a joke. You see, this is the kind of thing you say, oh, these scientists, they say they had a good idea when they took their bath. Okay, that looks like a joke. But it is true. You can, when for instance, listening to a talk, maybe by Frank Wilczek or by Cirac, this can bring to me suddenly a connection which I had never made before. And maybe it has absolutely no relevance for them, but it may have relevance for me. So I think imagination is very important, and imagination is present in art, and imagination, of course, is very important in poetry. Now coming to music, since that is what I'm more sort of in, is that music, especially, at least the way I feel it as a chemist, music has a structure and a time dependence. It evolves with time. And chemistry has a structure, vertical, horizontal, even three-dimensional. Now musicians have tried to make three-dimensional structures by putting instruments different places in the room, like Xenakis and other people like that. And also the time dependence is very important. Once it's gone through, it's there. You cannot change it. That is also what makes music very difficult. When I give a talk, I can correct myself. When you play a sonata and make a mistake, you can start again, but that mistake is there. So I think art, and in general, is very important for scientists. Some feel it more in words, in expressing themselves in words. Others feel it in painting, in sculpture. Sculpture, in fact, is quite close to chemistry in some ways, because the shape of a sculpture, I could show you a number of molecules which look like sculptures and conversely. And in fact, oh, that's too bad, I don't have the picture here. There is a very specific point. Of course, if I go to the Chilita Park, I can maybe make connections with some of those sculptures and some molecules. But even more, you will have to say something about that, perhaps, no?
I want to organize that.
You want to organize that. But I went there twice, so it's fine. There is a chemist in the University of Veszprém in Hungary. He's an inorganic chemist, and he turned a sculpture. And he makes very nice sculptures of molecules, which, even if you're not a chemist, are very nice. It's a pity that I can't show them to you, but they're very impressive. Let me see just one I could sort of represent with my hands. It's a sculpture which is like that, like a sort of a, fumes coming out of something, see, like this. And in fact, he used for this sculpture a molecule, phenyl ethyl alcohol, which is the scent of a rose. A rose, the molecule which makes a scent of course, a rose has a very complicated smell. But the smell, the dominant smell of a rose is an alcohol, phenyl, CH2, CH2OH. When you put that H, O, C, C, phenyl, you have this thing which looks like a sort of a smoke coming out. And that was very impressive. And he has many things like that. So he takes molecules and makes them into a sculpture. If you are not a chemist, you still find them nice. If you are a chemist, they have even more meaning. That's also what I say it's about music. Music, there's one approach. You like it, you don't dislike it, it fits with you. But if you know some music, you see a structure in it. A Beethoven quartet is very different when you know how it's structured and when you feel it the first time. It doesn't mean it's better or less good, but it's very different because you see an intention behind.
I was going to say that I was going to say that next time we organize Passion for Knowledge, maybe if we do. But in addition to this meeting, we will take Professor Len with all of you to Chilita Park, and he will come with his molecules, and it will be a practical lesson. That's what I was going to suggest. But in any case, I was going. En cualquier caso, I was. En Spanish. Quiero sugerir una cosa a los profesores de aquí. Ya que esto está poniéndose tan interesante y algunos que habéis venido de fuera, yo sugiero que los profesores, nosotros no tenemos el presupuesto tan alto, invitéis a los alumnos a comer en San Sebastián y os quedáis hasta la noche para que todos podamos asistir a la lección de Len. Bueno, a ver si recogéis el guante, yo creo que lo debéis hacer. Y en cualquier caso, los alumnos, si no os invitan a los profesores hasta que estéis a lo de Len, pues protestáis en vuestro colegio a la vuelta.
I'd just like to say that a remarkable theme of modern physics, starting really in the mid-20th century, has been how fruitful it's been to look for beauty in the equations, to try to make the equations more beautiful. This has turned out to be a very important guide to guessing the laws of nature. The ideas of unification I talked about. Our theory of the strong interaction is based very, very heavily on ideas of symmetry and making the equations as beautiful as they can be. And what's remarkable is that nature seems to have, in its fundamental interactions, some of the same aesthetic sense that humans do. A love for symmetry, a love for a certain kind of abstract simplicity. And we've learned that Mother Nature has really good taste.
Venga, seguimos con una pregunta sobre ciencia. Había muchas para Frank Wilczek. Espero que si sale otra, Pedro no se enfade conmigo.
No. I want everybody to have his share of questions. But obviously, Wilczek is a very lucky guy because the ballot goes for him one after the other.
He tenido mala suerte. Pregunta número 76, Lizardi Institutua. Eta Frank Wilczekentzat berriro.
Will the Large Hadron Collider solve all doubts about the Big Bang Theory?
Will the Large Hadron Collider solve all doubts about the Big Bang Theory?
Well, the short answer is no, but let me say what this Large Hadron Collider is. So it's a machine that's now starting to operate at the CERN laboratory near Geneva, where protons are accelerated to enormously high energy so that they're moving very, 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 very close to the speed of light, the limiting speed. And you have two circulating beams of protons in opposite directions moving around a gigantic ring that's 27 kilometers in circumference, straddling the border between France and Switzerland. And at a few points, these beams are made to cross, and there these very energetic protons collide with each other. And when they collide, they produce enormous concentrations of energy in a very small space. The energy involved is actually rather small. It's like the kinetic energy of a mosquito flying around, but it's in a very, very, very small volume. So if you convert it to a temperature, it's something like the energy concentration is something like the temperature of 10 to the 15 degrees Kelvin. So 1 followed by 15 zeros. Much, much hotter than the sun, either its surface or even the center. In fact, those kinds of temperatures were last achieved, according to our theories, in the earliest moments of the Big Bang, when the universe was something like a millionth of a second old. So we're producing directly a little bang. And so it's a very, very small volume and lasts only for a small time, but it's very much the conditions that we had in the early universe. So that will allow us to refine our ideas about the early universe. One important issue, for instance, is that astronomers have discovered that in addition to the ordinary matter that we are made out of and that we've studied very, very well for 2 millennia of science, the matter that we now know is made out of quarks and gluons and electrons and photons, normal matter. There's some other kind of matter that is out there in the universe, and in fact, if you weigh it up and see how much mass there is in that kind of matter, it's about 5 times as much mass as there is in ordinary matter. This is the so-called dark matter that's actually transparent. That's why we didn't see it, notice it for all these centuries. But now we can see its influence on the orbits of ordinary matter, and we know it's there. But we don't know what it is. We know what it isn't. It's definitely not ordinary matter. It's got to be something different. Now, if it's there, it had to be produced during the Big Bang. And so in reproducing the conditions of the early universe at CERN, there's a chance that we'll produce again this dark matter, but now in a way that it's right where we want it, and we can study it in detail and control its production, so we'll be able to see what it is, if it's a particle, how much it weighs, how it interacts with other things, and so we may very well figure out what this dark matter is. So we will definitely be refining our ideas about the very early universe, learning more about extreme conditions. But we won't exhaust it because, even 10 to the 15th degrees Kelvin is not infinity. And our theories of the Big Bang postulate much higher temperatures even. And at a certain point, things get very murky and mysterious. So at that point, we have to rely not only on experiment, but on our noodles to guess what's going to happen. And the LHC will put some constraints and give us some guidance about these guesses, but it won't answer all questions.
Frank, I also want to learn something. I'm not here only to talk with these people here. Some of the cosmologists say there was something before the Big Bang, and the Big Bang was a contraction of something before. What do you think of that?
Well, that's,
So one of the issues is that so we have very good evidence from many, many different kinds of measurements and experiments and observations that the universe was very much denser and hotter in its early history, and that it's been expanding and cooling for a long time. That's what we call the Big Bang theory. And so trying to extrapolate in the simplest possible way, we try to run things backwards and say the universe got really, really super duper hot and super, super dense. And eventually, however, the conditions are so extreme that our theories break down. We don't have theories for the ultimate beginning, the ultimate temperatures, the very highest energies. Our equations break down. They develop technically what are called singularities. So they just don't tell us anymore. They refuse to predict what it would be like. And so there are speculations. There are speculations that maybe we're sort of the outcome of a previous universe that expanded for a while, then gravity pulled it together, and so there was a big crunch, and then there was a rebound, so a bouncing kind of universe. Or other ideas are that the whole nature of time breaks down. This was actually St. Augustine's idea that in the early universe there were he said there were no clocks, or no minds to understand what time is, but now we would say there are no clocks. There's no clock is tough enough to withstand these conditions, or the whole notion of time goes away. But these are speculations. We need better theories to tell us at present, better equations so we can really address these questions. And these specific ideas about bouncing universes, I think, are particularly dubious, so I don't They need work, let's put it that way.
Con esta pregunta lo cierto es que hemos respondido más de una de las preguntas que había en la lista, así que si luego salen tendremos que quizás sacarla de nuevo. Vamos allá con una pregunta general, de opinión. Hogeita bigarrena, la número 22, por el Colegio San Pelayo.
No, yo creo que es necesario salir de cualquier sitio para ser un buen científico, ¿no? En todas partes del mundo lo que uno hace es que estudia en un sitio, hace tal vez una tesis doctoral en ese sitio y luego se va fuera, se va al extranjero, se va a Estados Unidos, se va a otro sitio, simplemente para aprender nuevas técnicas y para abrir su mente. Es algo que es muy importante y en lugares como Alemania, como en Estados Unidos, pero en el caso que conozco yo, el alemán, pues es casi una obligación, es una obligación. Tú no puedes sacar una plaza de profesor de universidad si no has estado fuera durante un tiempo. Así que yo diría que sí que es necesario, pero no es necesario por un problema de que el lugar que esté no sea lo suficientemente bueno, sino es necesario para poder abrirte y aprender cosas nuevas y aprender nuevas técnicas y conocer a otra gente y aprender a hablar en público delante de otra gente. Eso es muy importante, creo yo, imprescindible.
Seguimos. Del mismo bote. Ez du irekin nahi. Orain bai. Zortzigarrena, Axular bigarren hezkuntzako institutua.
Zer esango zenioke ikasle bati zientziak ikasteko konbentzitzeko? Ezaugarri bereziak behar dira zientzialaria izateko?
I think, first of all, as I wrote in that book, science shapes the future of mankind. Participating in that is most exciting. Now, what do you need? A lot of hard work. It's not falling down the sky very simply. And often people tell us, yeah, you should explain what you're doing. It's too difficult. We don't, for instance, chemistry. We don't understand chemistry. It's too complicated. But when you play tennis, you are ready to do 4 hours or more than that tennis a week to train. So why don't you do 4 hours of chemistry? If I want to learn Basque, I have to do hard work to learn it. So everything is hard work, and the reward is to understand. Some people are able to understand more quickly than others. That depends on lots of things, but I think science is a goal. Science is being part of an enormous enterprise to understand the universe, what we are doing here. We bring a stone. It can be a small stone or a big stone, but when you contribute to science, the stone you bring is yours. And I think that is a very important feeling. Furthermore, science is extremely important for us as a society. If we had a more rational approach, we would be much better off in the world. Much of our reactions are still controlled by the old brain. We have in our brain many sections, and one is the paleo brain, the old brain, which depends on adrenaline, hormones, fight and flight, running or fighting. Okay, that's important. It's part of us. But we should be able to control that more, and I think in that respect also the rational approach which science could bring to mankind would help us a lot. So all of you who will become scientists, you will contribute also to mankind.
I will make a comment later about Basque, but now France and Iraq.
Okay. I'd just like to add that there's no one personality type that makes a scientist. There are many different kinds of people in the scientific community with different talents, different interests, different personalities that can make important contributions. So one type is like me, someone who likes puzzles and mathematics and becomes a theoretical scientist. Other people like more to play with toys, to build things. They may become experimentalists. Other people, very important, have skills in interacting with other people. So many scientific challenges also have to do with the needs of society. Problems like our climate problems and energy problems are partly scientific, but also partly economic, partly sociological, partly political. And we need people who are comfortable in all those things. So when you're thinking about becoming a scientist, you shouldn't be thinking of someone who wears a white coat all the time and spends all their time in a laboratory. There are many, many different kinds of people who contribute to science. And it's a great not only community, but a great world of communities that you can think about joining.
Sí, bueno, yo quería añadir a lo que han dicho los demás, aparte de, por supuesto, intentar convenceros, algunos de vosotros que estudiáis ciencias, quitaros el miedo. Yo lo que veo es que mucha gente de vuestra edad ve la posibilidad de estudiar ciencias como algo muy lejano, muy arriesgado, que no sabe si le va a gustar, que no es tan seguro, que bueno, leen los periódicos, que algunos científicos no tienen plaza fija, que otros están en el extranjero, no sabes lo que vas a hacer. Y hay un poco de miedo a dar ese salto, ¿no? Existen otras profesiones en las que, bueno, si se te dan bien las matemáticas, la física, la química, pues puedes hacer carreras, ¿no? Económicas, ingeniero, etcétera, etcétera, ¿no? Bueno, pues en el lado de las ciencias, realmente yo creo que hay que quitarse un poco el miedo, ¿no? Uno puede estudiar ciencias y hacer muy buena carrera como científico, también como ingeniero, trabajar en una empresa. Es decir, el estudiar una carrera de ciencias te hace una persona versátil que te abre muchas puertas. Una de ellas es el de la investigación. Si luego te gusta, tienes la oportunidad y si eres para ellos, pues te puedes dedicar a la investigación y ya dependiendo de lo que han dicho anteriormente, si te da bien pues el pensar, otra vez trabajar más con las manos o tener pues un cálculo muy rápido, pues ya te puedes encajar en el tipo de investigación que puedas hacer. Pero si no te gusta o resulta que no sirves o que sacas malas notas y no puedes tener una beca, bueno, pues existen las posibilidades de irte a trabajar en una empresa, en una industria. Y esto es un poco el problema que yo creo que existe en España, ¿no? Que no existe esta idea de que uno que estudia una carrera de ciencias luego se puede dedicar a la empresa y hacer una misma carrera que haría si estudiase una ingeniería. Es algo que hace falta cambiar y está cambiando. Y cuando vosotros lleguéis, yo supongo que estará mucho mejor de lo que está ahora. Así que no solo animaros a que estudiéis, sino quitaros el miedo. Estudiar una carrera de ciencias, aparte es lo que os lo vais a pasar bien, vas a tener que trabajar duro, por supuesto no te van a dar nada hecho, pero te va a abrir muchas posibilidades y una de ellas es la científica y esa posibilidad de hacer ciencia es extraordinaria, ¿no? Pero si no os gusta o no se os da bien, vas a tener otras muchas posibilidades. Así, tal y como estáis vosotros ahora mismo, es una opción realmente buena el hacer una carrera de ciencias.
Okay, I would like to tell Jean-Marie that Basque is the oldest language in Europe, is music and is poetry, and with a mind like his mind, he can learn Basque in 300 hours. So I am prepared to invite him for a month to San Sebastian and pay his course, and I will be honored if he accepts. At the same time, I will pay the course from my own money. At the same time, he can give a course to all the students like that. And now I will make some comments about the science in Spanish. Yo estoy totalmente de acuerdo con lo que se ha dicho aquí, pero además la frase de Wilczek es esencialmente que no existe el científico, hay científicos muy diversos, con distintas motivaciones. Él ve belleza en la simetría, probablemente un biólogo no tenga el mismo concepto de belleza que un físico como Wilczek, pero cuando uno lee, por ejemplo, el libro, y recomiendo leer La doble hélice, de Watson, ahí ve claramente qué distintos tipos de científicos hay, incluso en altura moral. ¿Por qué no decirlo y andar con understatement? El tratamiento de Watson a Rosalind Franklin muestra que Watson no tuvo en ese libro la misma altura moral que tuvo en su descubrimiento de la estructura doble hélice del ADN. Hay gente de todo tipo. Y luego hay una cosa que yo creo que en la línea de lo que decían Jean-Marie Len, Ignacio Cirac, es muy importante enfatizar o resaltar, aunque ellos lo han dicho y obviamente yo no voy a superar su descripción, porque no se puede, ni pretendo tocar el piano enfrente de Franz Liszt o de Chopin. Pero es que en la juventud, sobre todo en vuestra edad, hay un gran deseo de ayudar a las personas, de ayudar a hacer cosas útiles, de ayudar y ser generoso. Y la ciencia, con un entrenamiento que a veces en el proceso de aprendizaje es duro, como es duro, no tan duro aprender más, pero como es duro aprender inglés al principio, pues puede ayudar a solucionar muchos problemas de la sociedad. Y hoy lo decía, creo, en otra forma Cohen-Tannoudji, pero si no lo digo yo ahora, muchos de los grandes problemas que la humanidad va a tener que afrontar, como es, por ejemplo, la alimentación, la energía, el medio ambiente, el crecimiento de la intolerancia y de los fundamentalismos, no se solucionarán con menos ciencia, sino con más ciencia y con jóvenes dedicándose a la ciencia. Y para eso son precisamente estas jornadas, no solo para la ciencia es internacional, con valores comunes que trascienden nacionalidad, etnia, raza, edad, clase social, lo decíamos en el curso ayer, y yo creo que esto es algo que a un joven de aquí y de cualquier sitio no solo le puede ser útil, sino atractivo como proyecto. Pero tampoco pasa nada porque si no lo hace, porque los otros campos del conocimiento son tan válidos, tan respetables y tan atractivos como la ciencia. No hay el agua pura, si un científico creyese, Maxwell decía que el test más importante de un científico es saber a qué problemas se puede aplicar el método científico. Entonces, nosotros los científicos, y estoy seguro que los que me acompañan en esta mesa, no creemos que la ciencia es la única forma de conocimiento verdadero, ni que el que no hace ciencia se ha equivocado. Porque si pensásemos en eso, seríamos como el agua pura. Y el agua pura produce cretinismo, porque hace falta impurezas de yodo para la tiroide.
Bueno, al tanto de esta discusión que ha surgido ahora, me vais a permitir hacer trampas e incluir una pregunta que no está en la lista del encuentro sí ha salido para la del encuentro del próximo jueves, pero no me resisto a hacerla aquí, que es, viendo aquí estos 4 científicos, y remarco la O, es preguntar si la ciencia es un mundo de hombres.
Well, I hope not. Well, this is a hat I wear that is called Lyric Semiconductor, and this is my daughter's company. So women can be scientists, definitely. We encourage it. We could use more of it. And as I said, I think what frightens women away from science is lack of knowledge that, as I said, there are many, many different kinds of scientists, and it's a life that science is offers a number of lifestyles and choices that that people can follow, and it doesn't commit you to a rigid course of study or course of career. You can build different kinds of lives around science. I think the opportunities are enormous. I think the interest is enormous, and if you're a woman thinking about going into science, we definitely want you. The community will welcome you, and don't be afraid.
Last year's Nobel Prizes had 3 women. Not so bad. Furthermore, I think, of course, we know in our society we have to help women to go further and to have a tendency to go far enough. On the other hand, science does not depend on sex. The end of science is universal. Doesn't depend on sex. The symmetry of his equations doesn't depend on whether you are a man or a woman. The molecular recognition between the molecules doesn't depend on whether you are a man or a woman. So there's no reason why, except for tradition, that women would be as good, not better, as good as men. The approach may be different. The outcome will be the same, but the approach may be different, the way you get to it. On the other hand, there's something which, as long as we, mammals, reproduce, the way we reproduce, it is clear that women have a harder life and have more merit. Being a very good scientist as a woman is much more merit than a man, because a woman is still needed to make new people in the world. And therefore, I think women have a fantastic role. And those who achieve to be good scientists, sometimes they have to sacrifice a part of their life, but not always. It's very hard. I must say, I admire women who are very good scientists, because they had to make a choice, either to do two things at once, both being a woman and a scientist, or maybe sometimes to sacrifice some part of what they could do.
Sí, bueno, yo creo que se habla muchas veces del papel de la mujer en la ciencia, y siempre nos encontramos con el mismo hecho. Hay muchas menos mujeres en la ciencia que hombres, sobre todo si hablamos de ciencias experimentales o ciencias más relacionadas con las físicas y la matemática. Y hay varias razones que supongo, no soy la persona que sepa más sobre eso, pero está muy claro que hay más dificultades para una mujer para dedicarse a la ciencia que para un hombre. Ya se ha mencionado anteriormente. Normalmente, pues, uno que quiere dedicarse a la ciencia, pues tiene que trabajar, como he dicho antes, pues en la universidad, luego tiene que normalmente irse al extranjero, pasar unos años en el extranjero, y no sabe cuál es su futuro, ¿no? Puede ser que su plaza esté en un país, esté en otro, esté en una ciudad, esté en otra, y eso da una falta de seguridad. Y eso hace, pues, que muchas mujeres ya de antemano, pues, no tomen esta iniciativa, y lo hace más difícil. Es una realidad y hay formas para combatirlas, pero es complicado. Así que yo veo realmente que hay un problema, y es un problema que tiene significancia, porque, claro, tenemos acceso en la ciencia, pues, a la mitad de la población de la que podríamos disfrutar, para que hiciesen ciencia con nosotros al mismo nivel o a un mayor nivel que el masculino, pues no pueden estar ahí. Y sí que creo que hay un problema detrás pero tampoco sé cuál es la solución.
Bueno, se me permita contarles una anécdota en relación con este congreso. Cuando nosotros empezamos a pensar sobre Passion for Knowledge, pues elegimos las personas que creíamos que iban a transmitir, que habiendo hecho contribuciones extraordinarias en el avance del conocimiento, podían transmitir esa pasión, y de una forma clara, sencilla y con gran capacidad de comunicación. Una vez que entonces les escribimos, y hay que decir, voy a contar una anécdota, que excepto 2 personas, todos los que invitamos han aceptado. Wilczek fue de los más difíciles, porque yo no tenía contacto con Wilczek, pero tuve que usar un embajador, el embajador Herschbach, y le convenció. Y eso me ha agradado mucho, porque luego me añadió en la comida que le convenció y no le convence de muchas cosas, que le pide hacer muchas cosas pero que casi nunca las hace, pero esta sí. Pero hay 2 personas que no pudieron venir, os digo también quién son. Uno es el cardenal, y no penséis que me acabo de ir que estoy volviendo loco y que no tengo nada que ver con el tema, que ahora entenderéis por qué. Tiene que ver mucho con la pregunta que se nos ha hecho a los 4. Por eso me tomo la libertad de participar también, a pesar de ser el moderador. El cardenal Martini no pudo aceptar porque tiene Parkinson. Hubiese sido interesante en conexión con lo que ayer Chechanover sobre la nueva biología y la ética. Otro que no pudo venir es el que explicó el teorema de Fermat, porque, según me dijo, le parecía apasionante el tema y estaría encantado de venir, y a ver si podía retrasar la fecha hasta el 2012. Nos pareció un poco tarde para celebrar la década del DIPC, pero luego, a raíz de eso, y ahora viene la conexión, hemos recibido alguna carta seria y bien argumentada diciendo que el elenco de ponentes es fundamentalmente masculino. Incluso alguna acusándome a mí personalmente de violar no sé qué leyes, no sé cuántos puntos de la ley de género de España. Nosotros, y aquí viene la gran pregunta, nosotros estamos totalmente a favor de potenciar y crear oportunidades para las mujeres. Pero ¿cómo se hace esto? ¿Se hace seleccionando ponentes de menor nivel que los hombres o creando las condiciones para que las mujeres, que tienen igual talento, obviamente, eso sería, insistir en esto es defender lo obvio, tengan la oportunidad de desarrollar? En definitiva, no poniendo las hormonas por delante de las neuronas o creando oportunidades iguales para todo tipo de hormonas. Esto es, nosotros elegimos a la única premio Nobel de Química que hay, viva, que creo, ¿no? Pero ¿por qué es esta situación? Y luego el tema del océano, Sylvia Earle, hay 2 mujeres. Entonces a mí me pareció ese ataque que se nos hizo injusto porque hemos hecho el máximo esfuerzo. Por ejemplo, que me corrija Franz o me corrija Jean-Marie, yo creo que solo ha habido 2 mujeres premios Nobel de Física en la historia. ¿Es correcto? Bueno, pues si me equivoco, me equivocaré en un 30% o así, habrá 3. Y químicas, pues 3 o 4, 3 y la actual viva. La única viva es la que está en San Sebastián, ¿no? Pero esto es lógico porque hay una historia de falta de oportunidades culturales. Antes he citado el tratamiento de Rosalind Franklin, pero 2 datos, y cito de memoria. Jean-Marie sabrá. ¿Cuándo se crea la Academia de Ciencias de Francia? ¿1667 puede ser? Pues yo creo que la primera mujer entró en 1979, ¿puede ser? Y yo le decía al venir en el coche a Jean-Marie, con otra conexión, que liberté, equalité, fraternité, pues horietatik bat egia balite, como se dice en Euskadi Norte. ¿Cuándo se crea la Royal Society? No me acuerdo, pero probablemente 1662, 63, no me acuerdo. La primera mujer creo que entra en 1945. Estamos viviendo una consecuencia de una falta de tradición en las oportunidades. Y yo creo que nosotros en este congreso, y aprovecho para explicar por estas cartas son personales internas, pero quería compartirlas con vosotros, hemos hecho un esfuerzo grande en traer a muchas, a mujeres científicas, pero nunca puede ser a costa de la cuota. La cuota yo creo que perjudica a la mujer que se esfuerza. Otra cosa es que para llegar a la igualdad, en la etapa de transición haya que hacer cuotas en muchas cosas, que yo también estoy a favor porque me dicen los abogados que si no esto no se corrige nunca. Un poco largo esto, pero aprovecho la oportunidad que me ha dado esta pregunta.
Venga, jarrituko dugu biografiari buruzko beste galdera batekin. 18. Marianistas ikastetxea.
What inspired you to start in science and to work in your respective fields?
What inspired you to start in science? Quizás ya ha sido contestada en las intervenciones iniciales, ¿no? But you want to add something? Or you think has been asked? You think? Yeah. No, esto no es para devaluar la pregunta, la chica que ha hecho la pregunta, sino al contrario, se ha anticipado a lo que ellos iban a decir al principio.
55. Orduan, Lasarte Usurbil bigarren hezkuntzako institutua.
Ba alduzu seme alabarik, hauek zure ere motera bultzatzea lortu alduzu, eh?
I have 2 daughters, and one of them is a professor of biology, and the other is, I mentioned, is working has degrees in mathematics and computer science, and now is working in the semiconductor industry.
We have 2 sons. One is a writer, and the other one a musicologist.
Yo tengo 3 hijos, la mayor tiene 17 años y quiere estudiar medicina o biología, todavía no lo tiene decidido. La segunda tiene 15 años y en estos momentos yo creo que no está pensando en lo que va a estudiar. Y el tercero tiene 6 y lo que más le interesa es el fútbol.
Vale, jarraituko dugu zientziari buruzko beste galdera batekin. A ber, norentzat ateratzen dan. 33. Bueno, es una pregunta que puede valer para todos. Gurutzeta, bigarren hezkuntzako institutua.
¿Cuál es la investigación más importante que habéis realizado o estáis realizando?
Atera da ere zuek ikusi.
I think if you consider that you have already answered in your introduction, if you want to add something? No. Yeah. Yeah. Well, they were very han sido muy humildes porque han realizado muchas y muy importantes y solo han dicho algunas, pero si ellos se dan por satisfechos y no quieren añadir, pues pasamos a otra.
Venga. Berrogeita hamabigarrena, 52, Instituto de Educación Secundaria, Usandizaga, Peña Florida.
Espera, Enrique, profesor Len va a añadir algo.
I think I wanted to mention something about the previous question, something which we did not succeed in doing and would have liked to solve, which is after the first oil crisis in 1973, we were very interested in a very, very simple chemical reaction. How you can use sunlight to split water, H2O, into hydrogen and oxygen, which of course happens in plants. That's part of photosynthesis. We worked a lot on it. We produced systems which were able to generate hydrogen or oxygen from water, even hydrogen, oxygen together, but they were very low yield, totally useless for the moment. So I would say that the question came up, what is important? I would say one of the most important chemical processes, both fundamentally and maybe for application in many areas, especially energy, would be to be able to split water with sunlight. But I have no good ideas for the moment.
Sí, bueno, yo quería añadir que es muy difícil muchas veces el juzgar de lo que estás haciendo que es importante o que va a ser importante. De hecho, en el trabajo, mi experiencia personal, cuando nosotros hicimos los descubrimientos hacia el año 95 sobre los ordenadores cuánticos, no teníamos ni idea de la repercusión que iba a tener. Habíamos hecho varios trabajos y este era uno más. Y solo fue pues que por casualidad o por suerte o por lo que sea, la gente se empezó a fijar en ello y empezaron a trabajar otros y luego más adelante pues surgió como un tema importante. Es decir, que normalmente hay que esperar un tiempo para saber qué es lo que es importante y qué es lo que no. Si no, pues todo el mundo trabajaríamos en lo que es más importante ahora mismo. Y eso tiene su belleza también en la física, ¿no? O en la física, en la ciencia en general, que no está muy claro qué es lo más importante en el futuro. Y normalmente lo que ocurre es que lo más importante en el futuro es algo que ahora no sabemos y que está ocurriendo.
Jarraituko. Venga, otra pregunta del bloque o del bote de opinión. Iritziari buruzko beste galdera bat. 73garrena. Lauro ikastolak egindakoa.
Are science awards a positive thing? Is not there a risk of becoming complacent? Do prizes open the possibility to start new projects?
Are science awards a positive thing? is not there a risk of becoming complacent? Do prices open the possibility to start new projects?
I think prizes are great, and there should be more of them. Well, yeah. But I do think one thing I think would be healthy if it would be to have some more directed prizes, if they were wisely directed. In the 19th century, the French Academy held a number of contests where they would ask for papers on a certain subject that and give a prize for the best essay or best scientific work on that subject. And I think that would be a really interesting kind of direction that seems to have been abandoned. I think there are specific areas of science that could use the encouragement that a prize would give. I think, for instance, right now, my perception is that biologists are beginning to get a grip on the really fundamental question of human health, which is the issue of aging. And I think prizes directed towards that field would help to encourage interest and progress in that field. But in general, I think prizes are really good. They inspire people to work, and why not? And, if the film people can give prizes for Oscars and get tremendous enthusiasm and interest, I think why not science? And it also, I mean, and of course, particularly the Nobel Prize, I think, is very important because the public recognizes it, and it creates tremendous interest in science and also produces credible spokesmen for science. And I think that's very important.
I certainly agree with what has been said. Prices, I don't think we are running for the prices. Of course, we are happy when we get it, very happy, I must say, that is clear. But frankly, it should not change our life. I must say some of our colleagues, their life has changed, and I don't approve of that. I think maybe Frank knows that too. Some people, let's take the Nobel Prizes, he mentioned that. If Nobel Prizes would not exist, we would not be here, probably. We would not talk to you. So what just Frank mentioned, that it is important because it makes also science available to the public. And that is probably, for me, what the Swedes have done the best. The Swedes have succeeded to make newspapers and TVs interested at least once a year in what is going on in science. I think that is quite fantastic. Huh? These people up north, by doing a good selection, not the only ones. I think other people could have gotten the Nobel Prize who didn't get it. But they select usually what we hope is good science. So it's brought to people, and they have this tremendous influence that science is brought to the public at least once a year. And as a repercussion, these people who have been distinguished by these committees up north are able to talk to you. And that's, I think, very important. Let me just mention that among the people, for instance, who should have gotten the Nobel Prize for sure, is Mendeleev. Mendeleev, the person who organized the elements of the universe in the periodic table. This is, for me, one of the most fantastic advances in science. Again, I will mention that this evening, but of course Frank would say, yeah, but there are other particles. That's true. But if you look at the table of elements of Mendeleev, you look at a table which tells you everything in visible matter in the universe. Isn't that fantastic? You see it in front of this table and you know that invisible matter from the planet Earth to the end of the universe. That's it. This is fantastic, no? And so Mendeleev, I think, I make a case for Mendeleev, a bit too late. But there's one. And as I said, this is just an example to say that there are prices, as Frank Wilczek said, maybe not enough. Other people could have gotten a Nobel Prize or other high prizes, and there are other high prizes. And these people who got the other prizes should also be interviewed, and they should be listened to, and they should be brought to the public. It's coming, but okay, it's a bit slower. And so you have to try not to be complacent. You have to try to remain yourself, to use it for good purposes. And at the end of it, it makes also life easier and more complicated. We know that. It makes it more complicated because you get many invitations from all kinds of people. But people know you are busy, so you can turn them down more easily. But many of those are very interesting invitations, and being able to speak in general public, it's a sort of a pleasure also to communicate.
Sí, bueno, yo quería decir algo muy brevemente, más una anécdota que otra cosa. Sí, es cierto que los premios son muy importantes y en especial los premios Nobel hacen que la ciencia pues la vea el público en general. Y han comentado anteriormente que la gente no está obsesionada con los premios Nobel, ¿no? Los científicos, pues uno no piensa, voy a hacer esto para ganar el premio Nobel. Pero sí que se ve de vez en cuando que hay alguna gente que sí que está un poco obsesionada, algunos científicos, con los premios Nobel, con recibir el premio Nobel, ¿no? Y hay un caso en particular, no diré el nombre, que es una persona que parece que sí que está, que todo el mundo conoce que está obsesionada, ha hecho trabajos muy importantes y cada año pues el 11 de octubre o el 10 de octubre cuando se anuncia pues está muy pendiente de ver qué es lo que ha pasado. Y esta persona, una vez estábamos en una conversación y dijo que, pues como tenía esta fama, pues la quería quitar un poco de encima y dijo, no, lo que tendríamos que hacer es dar los premios Nobel cuando uno ya se haya muerto, para que así pues no haya tanto pues, o sea, lo que sea, ¿no? Y otro que estaba allí delante le dijo, pues yo sé que hay más de uno que se suicidaría.
Sí, fantástico. Yo estoy de acuerdo con los que han hablado. Yo creo que los premios son muy importantes. Y voy a aprovechar ya, esta es ya la última pregunta para cerrar el evento, especialmente el premio Nobel, porque se convierten en embajadores de la ciencia. Pero también otros premios. Y este evento no hubiese tenido lugar sin algún premio. Yo empecé el DIPC, premios muy inferiores al premio Nobel, pero en aquel momento hubo una conjunción, el premio Príncipe de Asturias, que también Cirac tiene, el premio Iberdrola, en el cual Jean-Marie was en el jurado, obviamente la simpatía que tengo por él no podía aumentar, pero desde luego no disminuyó a raíz del premio Iberdrola, y el dinero del premio Max Planck. Ese dinero fue el inicio del DIPC. Y pudimos con ese dinero, el dinero del premio Max Planck para cooperación internacional, convencer a las instituciones que apostasen por este proyecto y convencer a los privados. El caso concreto del Donostia International Physics Center y la reunión de Passion for Knowledge no hubiese sido posible sin esos premios, muy inferiores al premio Nobel. Los premios Nobel son embajadores de la ciencia y desde luego producen una satisfacción tremenda, hasta el punto de que Franz Wilczek, como estaba tan convencido que le iban a dar el premio, pues no dormía la noche en que se anunciaba y estuvo 5 o 6 años sin dormir. Y el año que le llegó también estaba despierto y se fue a la ducha. Y allí le dio su mujer el teléfono móvil con la llamada de Estocolmo, que fue larga y no sé si pudo secarse o no secarse, pero desde luego no fue una ducha de agua fría, como se dice en España. Eso es verdad. Franz recibió la noticia del premio Nobel en la ducha, y yo creo que para acabar les pediría yo a los tres, Cirac, además de premio Príncipe de Asturias, que es un premio muy mediático, también le convierte en un embajador, vete a ser pronto, igual recibe una llamada, espero que no le coja en la ducha, tiene también la medalla Franklin. Yo les pediría a los tres que cuenten brevísimamente cuál fue aunque yo ya me lo sé, Jean-Marie creo que estaba entrando, que cuenten el momento en que recibieron la llamada brevemente y con esto concluimos la reunión, agradeciéndoos de corazón vuestra asistencia, las estupendas preguntas que habéis formulado, el venir aquí e insistiendo en lo que he dicho antes, comida en San Sebastián y luego todos, en vez de ir al cine, a la charla de Jean-Marie Len.
Right. Well, let me add a few details to the story. So, he's right. For several years, I had been anticipating that this might happen, and I knew when the announcement was going to be made, and the night before, I had a lot of trouble sleeping. I knew not only the date, but also the time that the announcement was going to be made, which is 6 o'clock in the morning, Boston time. And in 2004, I was not sleeping, and I looked at the clock from time to time, and at 5 o'clock, I said, okay, you're not sleeping. You might as well take a shower just in case, so you'll be ready if they call. What I didn't know is that that the call precedes the public announcement. So I was in the shower at 5:11, taking a shower, when the call from Stockholm arrived, and I didn't hear it. My wife picked up the telephone and came into the shower with our mobile phone and said, there's a lady calling who has a Swedish accent and says she wants to talk to you. And that was it. And so I took the call, got out of the shower, did not stop to dry off, much less get dressed. So I was sopping wet and completely naked, taking this phone call. And the other thing I didn't anticipate was that I thought the call would be congratulations, you've won the Nobel Prize, goodbye. But it's not that way at all. They wanted to explain the citation, explain how to deal with the press that's going to come, the kind of clothes you have to wear when you come to Sweden, all kinds of practical arrangements. And then the President of the Academy wanted to say a few words, and then the President of the Committee wanted to say a few words, and then the various friends from Sweden wanted to say a few words. And so altogether, I was probably talked to a dozen people and for 20 or 30 minutes, and all this time I was still soaking wet and naked. Nevertheless, it was a very positive experience. I didn't really feel cold or very disturbed. It was another level of consciousness, and it was joy. And then the first thing I did was call up my parents and tell them it was really quite magical. Yeah.
It was quite different. I was not in the shower because it was not 6 o'clock in the morning. You know that something is going on because the nominations for the Nobel Prize have to be done every year before the 31st of January. So if your secretary gets many requests for CV, biographies and so on in November, December, so you know that something is going on. So I knew that something was going on. But I had accepted to give a talk at Stanford at the Johnson Symposium, and I had my ticket for flying to San Francisco. I was sure more, I didn't think about so much. I said, okay, I mean, it may happen, may not happen. And so this was the day before I was going to fly to San Francisco. So I went from the lab home to have quick lunch on foot, where maybe I could walk home, and then walk back to the lab. And that's when my wife got the phone call. It's always the wife who gets it first, Frank, isn't it? And so what happened was very funny, because he unfortunately died, a very good friend, excellent chemist, John Osborne, the one of the Osborne-Wilkinson reaction. And he usually was making fun in October of me. He said, I sort of joking about the Nobel Prize. So he was joking. And so I came out the elevator, and John was standing in front. He had gotten a phone call from my wife. He said, Jean-Marie, you have the Nobel Prize. John, cut it out. I have other things to do. But then I went to my office, and the phones began to ring. And then you forget. You just follow the moment, because you don't think much, because many things happen. Well, you let it go. You learn how to adapt. And you also learn, and very quickly, how incompetent in science TV people are. Because the TF1, the first channel in France, they came around and sort of asked me things. And the conclusion of that guy who had interviewed me for, I don't know, half an hour, was he has discovered the molecule. There was a big laugh in the lab.
Bueno, yo desafortunadamente no tengo tanto que contar como los anteriores. Bueno, yo voy a hablar de lo que pasó el día 10 de octubre del año pasado. El día 10 o 9 de octubre es la noche es el día en que se anuncian los premios Nobel de Física. Yo estaba en el Perimeter Institute en Canadá, es un instituto de investigación, haciendo una estancia de 3 semanas. Y bueno, estaba durmiendo y a las 2 de la mañana me llamaron al teléfono móvil. No sabía nada y cuando me desperté, pues bueno, por el cambio de horario, ¿no? Debía ser una llamada desde Europa. Y vi que era un número que llamaba desde España. Entonces fui a dormir otra vez, al cabo de un tiempo me llamaron otra vez. Otro número de España, también llegué tarde. Y al cabo de un rato pues me llamaron otra vez. Entonces cogí el teléfono y me llamaban de la radio Radio Nacional de España creo que era, y de otra radio. Y la cuestión es que, no sé cómo, había salido en algún periódico, en El País creo, que yo era candidato al premio Nobel, no sé dónde había sacado eso, bueno, había una empresa que había hecho unos cálculos y no sé qué, pero bueno, se salió el rumor y bueno, pues al final tuve que apagar el teléfono móvil porque es que no dejaba de sonar y no podía dormir, ¿no? Así que esa es mi experiencia con el premio Nobel.
Bueno, pues ya para concluir esto, we want to know, Jean-Marie, whether you took the plane or not. Did you go to the meeting?
Yes, I just postponed it by 1 day. I wanted to go to the meeting. My secretary had to take all the phone calls. I was a bit safe being far away. And so I went anyway to the Johnson Symposium. One thing I could mention, I think Richard Ernst, who is also here, he got the announcement through the pilot of the aircraft he was flying in. Yeah, I think he was on the way from Zurich to Moscow or something like that. And he was in the air, and the pilot announced, we have a Nobel Prize winner on the plane.
Ernst habla hoy. Bueno, yo acabo con una anécdota. Primero agradeciéndoos a vosotros la asistencia, agradeciendo a los estupendos compañeros que me acompañan aquí, a Ignacio Cirac, a Jean-Marie Len y a Frank Wilczek, y deciros que yo tengo hecho un pacto con Ignacio Cirac. Si algún día, que yo espero, tarde o pronto, obtiene la llamada, la primera conferencia la dará en San Sebastián. Este es un pacto que tenemos, espero que no te hayas olvidado. Y entonces le volveremos a ver, aunque espero que sea pronto, pero será, y si no, muchas veces le veremos aquí, porque Cirac es el Messi del Donostia International Physics Center. En todos los partidos que jugamos es titular y va en nuestras alineaciones. Muchas gracias.
Jose Luis Elorza, etengabeko ikaskuntzaren zuzendari jauna, Donostia International Physics Centereko lehendakari jauna, Mr. Herschbach, Mr. Rohrer, Monsieur Cohen-Tannoudji, vous êtes le bienvenu, ongi etorriak, irakasle jaun andereak, zuek ere gaur jaun andereak zaretelako. Egunon eta ongi etorri. Thank you for your visit. You are welcome to Kutxa espazio. Mila esker, zientziagune honetan gurekin egoteagatik. Irakasleon artean, seguru asko ondo ezaguna zaizue kutxagunea. Gaur ez bakarrik ohizko zientzia tresnak eta guneak, baita zientzialari ospetsuak erakarri dizkizuegu. Dakizuenez, Passion for Knowledge kongresu honek Donostia International Physics Centerreko lehen hamarkada ospatzen du. Eta kutxarentzat ohore bada honen patroia izatea. Oso kongresu importantea izaten ari da, zientzialarin komunitaterako eta orokorrean guztiontzat ere. Ayer participaron en un acto similar a este los estudiantes, a quienes califiqué como los principales protagonistas de nuestra red de enseñanza. A los profesores debería deciros lo mismo, vosotros sois protagonistas también. En el gran escenario de la enseñanza y el aprendizaje, profesores y alumnos compartís ese protagonismo. Y es nuestro deseo que conozcáis y podáis convivir, siquiera por unas horas, con personas que pueden ser ejemplo al que proponer a vuestros alumnos como modelo a seguir el día de mañana. Más allá de ejemplo por sus logros, por sus actitudes y por sus valores. Os corresponde a los profesores la responsabilidad de desarrollar la capacidad de aprender de vuestros alumnos, casi nada. Pero tan importante como esa función, que no se circunscribe solamente a la etapa vital, será también la de inculcarles la necesidad de trabajar el interés y la curiosidad por aprender. Y eso es a lo largo de toda la vida. Baina kanpotik etorri direnetatik aparte, badauzkagu gure artean bestein beste ikertzaile eta zientzialari. Ospetsuena dudarik gabe, Pedro Miguel Etxenike landiri bar dugu, bera da zientzia alorrean munduan zehar euskaldunik ezagunena. Eta berari eta bere taldikideei gure onespena eta gure eskerrak eman behar dizkiegu kongresu hau eta gaurko ekitaldi hau burutzeko egin duten ahaleginengatik. La pasada semana celebrábamos muy cerca de aquí el acto de colocación de la primera piedra del edificio Biokutxa. Una infraestructura que esperamos llegue a ser trascendental para el futuro de la investigación en Guipúzcoa y que esperamos contribuya al desarrollo y bienestar venidero de todos los guipuzcoanos. Y aunque más importante que los edificios son las personas, nuestro sueño es que esos chicos y chicas a los que hoy estáis formando, que algunos de vuestros alumnos trabajen en el futuro como investigadores en ese edificio. Somos realistas y nuestra aspiración no es que forméis futuros premios Nobel, sino personas destacadas por los valores que practican y por los valores a los que representan. Que dejéis claro a vuestros alumnos que los premios Nobel que han tenido ocasión de conocer estos días y los que no siéndolo han llegado a ser sabios, no es por el conocimiento que han adquirido, sino por sus valores y sus actitudes. Esfuerzo, las cosas cuestan, resistencia a la frustración, empeño. Transmitidles, por favor, que estos admirados señores no han descubierto las cosas ni mucho menos a la primera, ni a la segunda. Son cientos de ensayos y pruebas los que han necesitado para llegar a descubrir algo. El futuro y el progreso de cualquier sociedad pasan necesariamente por su capacidad para innovar, por su potencial para investigar y por los recursos tanto humanos como materiales que pone a disposición de la investigación y del desarrollo tecnológico. Y también una sociedad avanza cuando sus jóvenes disponen de todas las oportunidades y apoyos para participar plenamente de esos recursos. Y en ese ámbito, Kutxa tiene una clara vocación de apoyar la ciencia y la investigación con mayúsculas. Los datos demuestran que somos una de las entidades líderes en lo financiero, cuestión importante en estos días, y también creemos y queremos serlo en todos los campos de lo social. Este zientziagunea que nos acoge es una muestra de esa voluntad, siendo como es una de las obras sociales de referencia para la sociedad y especialmente para la comunidad escolar. Finalmente, no quiero dejar de citar de nuevo las materias que en mi opinión están relacionadas con la ciencia. El arte, que no significa otra cosa que sentir y plasmar la sensibilidad. La tecnología, la naturaleza, En definitiva, todo lo que construye y rodea a la persona. Thank you for your attention. Mila esker zuen arretagatik eta opa dizuegu arrakasta handi bat gaur eta beti. Gracias y espero que todos disfrutéis de este día. Mila esker.
Good morning, everyone. I must say it is a great privilege and honor for me to be here today in the Encounter for Teachers as part of the events of the 10th anniversary of the Donosti International Physics Center and to be witness of conference gathered under such an interesting heading as Passion for Knowledge. Egunon guztioi eta Eusko Jaurlaritzaren izenean hitz pare bat esan nahi nituzke, zen izkenen nik uste protagonistak hemen gaur zuek zaretela eta izkenen Nobel sariak gurekin parte hartu behar duten ekitaldi honetan. Baina bai aurretik esanen nituzke bi hitz hezkuntza sailetik alegin batzuk egiten ari garela, gehien bat egoera, krisi egoera sakon honetan saltuta gaudenez, nolabait zerikusi zuzena duena ikerketa eta zientzi munduarekin, eta neurri batzuko pauso naiz eta orain arte maila txikikoak izan edo alegin batzuk egiten ari gara. Besteak beste dago txartela orain irakasleo jaso duzuenok, besteak beste horrelako hemengo rezinto honetara saltzeko posibilitatzen duen txartel horitako bat, besteak beste dago Eluiar Fundazioarekin sinatuta dugun konbenioa, orain ez dela asko, baitare badakizue irakasleen formakuntzarako garatu programan, besteak beste daude aurkezten dira programa batzuak, aurten aurkeztu da bat eta agian hemen zaudeten baten batek bat hartuko zuen Ginebrako CERN zentroan ikasketa batzuk, formazio batzuk jasatzeko eta abar. Quería decir en nombre un poco del gobierno vasco, pero en este caso voy a dejar un poco todos los papeles y sí tal vez reseñar una pequeña anécdota para acabar por mi parte esta intervención. Yo anoche hablaba con mi madre, entre otras cosas le comentaba que hoy iba a estar con una serie con unas personas que eran premios Nobel aquí. Y entonces de repente son de esas cosas en que te entra un poco el nervio y un poco el vértigo, porque dentro de mi universo infantil, en el mundo de las cosas en que yo imaginaba o podía soñar en que me podía mover en este mundo, desde luego el plano de los premios Nobel para mí era un plano que estaba en otra esfera. Era algo así, casi como extraterrestres, era algo muy inimaginable dentro de mi universo de posibilidades de conocimiento. Y sin embargo me doy cuenta que hoy estamos aquí en Donosti, que son personas de verdad, son seres humanos, que estamos hoy aquí, que espero que podamos compartir con ellos un rato ahora mismo. Dentro del lenguaje de sus trabajos y de sus investigaciones se habla de partículas, de átomos, de moléculas, matemáticas avanzadas, cosas de este tipo, pero de repente nosotros estamos aquí profesores, gente que estamos trabajando con alumnos de 14, 15, 16, 17, 18 años, la mayoría de las veces o muchas veces con situaciones comprometidas, difíciles, y yo tenía un poco la impresión de que a pesar de todo lo importante que es la ciencia y de que el trabajo en los laboratorios, las partículas, etcétera, siendo muy importante para todos nosotros, creo que la materia prima con la cual trabajamos los profesores es todavía más importante y es una materia prima infinitamente más sensible, que estamos trabajando con seres humanos directamente. Y todos y cada uno de ellos tienen un potencial enorme como tal, como seres humanos. Y entiendo que nuestro trabajo, como docentes, como profesores, es tal vez, aparte de esos requisitos mínimos que tienen que cumplir de exámenes, de pruebas y todo eso, ser capaces de conectar tal vez con ese alma que tienen cada uno de los seres humanos a los cuales nos enfrentamos cada día, y tal vez transmitiéndoles o ser capaces de encender alguna de esas luces o alguna de esas energías que todos ellos tienen de una o de otra manera en su alma, y ser capaces de que eso se pueda proyectar en su vida o pueda tal vez alcanzar un nivel que dentro de unos cuantos años, quién sabe, tal vez nos los encontremos aquí sentados en un acto parecido a este. Nada más por mi parte, espero que de alguna manera sea provechoso el acto de hoy y agradecerles en nombre del Gobierno, en cuanto me toca a mí, pues la presencia de todos ellos, a Pedro Luis Echenique, etcétera, que antes me he equivocado con el nombre, y en cualquier caso que disfrutemos todos del evento. Muchas gracias.
Bueno, egunon guztiei, eta eskerrik asko. Nik hasi baino lehen eskerrak eman nahi dizkiet batez ere Carlos Garziari eta Tere Santori encounter hauek antolatzeko eman diguten laguntzagatik. Bueno, ya primero le tengo que agradecer sus palabras al director de tecnología operativa, o es de aprendizaje continuo, José Miguel Elorza, o es José Luis, y de parte de Pedro Miguel Echenique. Well, you will not understand this joke, but it's because he has corrected what he called me before with another mistake. But science progresses correcting mistakes, no? So he must be a good scientist. En la intervención que ha hecho, ha mencionado la palabra crisis y la importancia de la educación. Yo me acuerdo de una frase de Cohen-Tannoudji hace tiempo, cuando recibió la medalla de oro del Consejo Superior de Investigaciones Científicas. Todo esto no está preparado, obviamente. Yo soy un gran admirador de los Ver Solaris, así que vamos aquí a improvisar un poco. Que él decía que los grandes problemas de la humanidad, como son el medio ambiente, la energía, la alimentación, la salud, el crecimiento de la intolerancia y los fundamentalismos, no tendrán solución con menos ciencia, sino con más ciencia y, sobre todo, con más educación. Obviamente, la educación no va a solucionar la crisis. La ciencia puede ponernos en condiciones, y la educación, de estar mejor preparados cuando acabe la crisis, pero no va a solucionar. Pero la ciencia se fundamenta en una visión a largo plazo. Hay una frase de Newton: si he podido ver tan lejos es porque me apoyo en las espaldas de los gigantes anteriores. No es de Newton, es de un teólogo 200 años después, pero también la dijo Newton. Pero hay otra muy bonita, André Gide, «C'est pour toi». André Gide: todas las olas del mar deben la belleza de su perfil a la retirada de las que les precedieron. Largo plazo. Significa que hay que apoyarse en los anteriores. Y por eso nosotros estamos dispuestos a aceptar que se inviertan cantidades ingentes de dinero en solucionar los problemas de los que nos han metido en este lío, como algunos banqueros americanos. Pero no sería entendible que no se invirtiesen cantidades ingentes de dinero en garantizar el largo plazo. La educación, la ciencia, la tecnología, la investigación y, sobre todo, la preparación de las personas. Esto es lo que me ha inspirado nuestro amigo José Luis, esta vez ya bien. La ciencia es una aventura intelectual, en palabras de Dudley y Herschbach, una aventura humana, que en los últimos años ha cambiado la concepción del mundo en que vivimos y de nosotros mismos. Consiste en saber escuchar lo que dice la naturaleza. La naturaleza siempre habla bien y nos lanza su mensaje, pero muchas veces no a gritos, sino sutilmente, suavemente, y hay que saber entender, y hay que saber aprender un lenguaje. Y en ese lenguaje, en el aprendizaje de ese lenguaje, hay esfuerzo, hay valores, hay ejemplos, y donde mejor se aprende, y yo les oiremos a ellos, es en la escuela. En la escuela. Por eso a mí me gusta poner como paradigma, y otra vez Dudley me lo enseñó, cuando él es un gran ciclista. El día pasado estuvimos en Lesaca, tomamos queso en el casino de Lesaca y chistorra. Desafortunadamente la chistorra del casino de Lesaca que nos dieron no es comparable a las que tomo en Guipúzcoa, y eso para un navarro como yo fue una cura de humildad. Pero ahí hablábamos que la enseñanza que representa y que es lo que ilustra mejor la ciencia como aventura es la que tuvo Anne Sullivan con Helen Keller. Helen Keller, sordomuda, que por cierto, detrás de ello está Alexander Bell, el descubridor del teléfono. Mucho más importante para ese descubrimiento fue su interés en enseñar a distinguir la P de la D que la ingeniería eléctrica o mecánica. Y entonces Sullivan consigue que aprenda de forma exponencial una vez que ella se da cuenta que las palabras tienen significado. Y cuando ella dice: cuando me di cuenta de esto, se despertó en mí la pasión por aprender, la pasión por el conocimiento, passion for knowledge, y aprendí exponencialmente. Y me cambió la vida. Eso es lo que hacen los profesores. Ya sé, yo soy profesor, ya sé que a los profesores se les carga con demasiadas exigencias y no se puede poner todas las esperanzas de todos los follones en el sistema educativo, porque eso es como, eso podemos crear entonces el reino de los eternos descontentos. Y yo creo que tenemos un grupo de profesores espléndido, y yo lo constato. Vamos a dar, por cierto, es tan bueno lo que nos ha ayudado Tere Campos, que hemos cedido a su pasión y vamos a dar un curso de nanotecnología en Nanogune y en el DIPC para todos los profesores de bachillerato que quieran apuntarse. Y hasta a mí, que soy muy reticente porque con los años me he vuelto más vago, pues me han puesto 5 horas de nanotecnología y de conceptos que daré muy a gusto a los profesores de bachillerato en noviembre. Entonces, pero los profesores son clave. ¿Y cuál es la mejor forma de lograr? Yo tengo una opinión. Yo no creo mucho, y con perdón, en metodologías, formas, tal. Yo creo en que si tenemos unos profesores bien formados, bien motivados y bien remunerados y bien tratados socialmente, esto va a ir cada vez mejor. Y van a enseñar habilidades, conocimientos, ética o formas de hacer las cosas, y también visión, ¿no? Pues las personas son importantes. Y nosotros nos encontramos con un problema. Surgía ayer a la hora de transmitir este conocimiento, también en las universidades. El crecimiento exponencial del conocimiento científico, que prácticamente se duplica cada 2 años. Y a la vez la necesidad urgente de interdisciplinariedad. Lo veíamos en la reunión con los médicos. Hoy la investigación médica la hacen los físicos, los químicos, los ingenieros químicos, los nanotecnólogos. Hay que ser interdisciplinario, pero a la vez la frontera va avanzando tan rápido que cada vez hay menos tiempo para llegar a ese conocimiento. Es una contradicción entre el avance exponencial, que exige una especialización radical para entender bien lo básico, que luego permita aportar algo en la frontera, y la necesidad de interdisciplinaridad, que solo se puede conseguir con la excelencia en la propia disciplina y aprendiendo a entender el lenguaje de los otros. Ya no son posibles los hombres del Renacimiento. Igual, y ese es el objetivo de un buen trabajo en equipo, como es, se me permita la autopropaganda, el Donostia International Physics Center o Nanogune, que tenemos un gran centro. Por cierto, Heinrich Rohrer es del comité científico de Nanogune y Herschbach es del comité científico del DIPC. Pero ya no es posible esa interdisciplinaridad más que con los equipos. Pero claro, Heinrich Rohrer ha dicho con gran acierto que las ideas siempre nacen en la mente de una persona, ni en organizaciones ni nada, y que lo importante son las personas y la creatividad de las personas. Y por eso hoy tenemos el profundo privilegio de tener ante nosotros, y yo me siento hasta emocionado, pues son amigos míos de muchos años, yo les he admirado durante muchos años. Tenía los mismos miedos que tenía José Luis, pero son, como veréis, aparte de grandes científicos, grandes personas y muy, muy directos, a 3 leyendas vivas de la ciencia. Empiezo, I'm sorry, Dudley, lo siento por el más, no viejo, pero el más maduro, el profesor Herschbach, premio Nobel de Química, profesor de la Universidad de Harvard, y que hay que leerle y ver cómo enseña. Cuando él me explicó que él pide a los alumnos que improvisen y escriban un poema sobre una idea, para ver si la llegan a entender en su profundidad. Yo estaba pensando en nuestros versolaris y el sábado vamos a ir otra vez en bici y voy a ver si consigo invitar a Egaña o a Mayalen Lujambio para que le cante un verso al tema que él diga. Es una leyenda no solo de la investigación, sino de la comunicación, de la pasión por la ciencia y por transmitirla a la sociedad. El profesor Cohen-Tannoudji es otra leyenda para quien, como yo, es físico cuántico. Yo creo que si yo tuviese que decir quién es la persona que nos ha enseñado a pensar cuánticamente, diría Cohen-Tannoudji. Y el libro de Cohen es como para nosotros la Biblia, lo que era antes la Biblia. Yo con mis alumnos de doctorado, Igor lo sabe, o Enrique me decía, en el desayuno, alguien nos pregunta una cosa, está en la página 37 del Cohen-Tannoudji. Un ejemplo de claridad sin perder el rigor. La conferencia de Herschbach y de Cohen-Tannoudji en el simposium de Einstein y de Rohrer hace 5 años son ejemplos de cómo se puede conjugar una transmisión del conocimiento certera, una pasión sin abandonar el rigor, haciendo verdad la frase de Einstein: las cosas hay que transmitirlas lo más sencillo posible, pero no más, porque entonces se transmite otra cosa. Y el profesor Rohrer no es profesor, él es doctor, solo doctor, porque ha sido siempre en empresas IBM, y él nunca le ha gustado, nunca ha querido enseñar currículos organizados, pero sus conferencias transmiten precisamente el título que él ha elegido a la conferencia, con que apropiadamente cerrará el ciclo de conferencias en el cursal de Passion for Knowledge el viernes. Tiene pasión, tiene claridad, tiene ciencia y tiene fascinación. Por eso quiero agradecer también a los que han venido desde Pamplona en coche, que no sé si han llegado, con Itziar Astiazarán al frente, el detalle que han tenido, y a los que nos habéis ayudado en estos encuentros. Y ya me he alargado mucho, porque esto es una nota que he tenido que hacer porque tenía todo bien escrito, mi improvisación la había pensado antes de ayer, pero con este follón se me ha olvidado en casa, o sea que he dicho lo que se me ha ocurrido, y la verdad es que yo estoy tan contento más que con lo que tenía preparado. O sea, podéis luego preguntar, ahora nos vamos a sentar ahí, ellos hablarán un poco, empezando por el doctor Rohrer, profesor Claude Cohen-Tannoudji, cerrando Dudley y Herschbach, y luego todo el diálogo que queréis. Diálogo hasta la 1:30, donde nos iremos todos. Cohen, podéis preguntar, castellano, euskera y traducción simultánea, inglés directamente si preferís, o al profesor Cohen en francés, y si alguien quiere lucirse en alemán, Rohrer también sabe alemán. Eskerrik asko beraz batez ere zuei eta eskerrik asko kutsari. Carlos Ruizek izan da gure laguntzaile edo gure agintari ez dakite handiena. Es un fan del DIPC. Organizamos unas lecciones escucha que fue idea de él para calentar motores en mayo, explicando los temas que se tratan en este congreso, que tuvo un éxito estupendo, fantástico entre los profesores de bachillerato, y ella anda ahora queriendo que organicemos más, etcétera, porque es una fuerza de la naturaleza. Probablemente yo ceda a sus demandas, pero tendré que pasar unos ciertos días después de este congreso antes de que me decida empezar algo nuevo. Muchas gracias a todos, perdonadme por haberme alargado. Eskerrik asko zuei, thank you very much to you. Now, Dr. Rohrer will begin. Heinrich Rohrer is, in addition to being a doctor, is a captain of the Swiss Army.
Okay. What do you want to hear? About me or about, I think maybe best about me, not about everything which goes through my head. So I'm a normal country boy, or I was a normal country boy. Now I'm a little bit older. I was reasonable in school. I wasn't a star. Actually, I just looked at all my school colleagues on the various levels, and it's quite interesting that in most cases, not in all, at a certain age, a few are the stars. And these stars disappear again on the next level and on the next level. So that means really you can perform excellently on a certain level, but it's always difficult to keep up with your performance. And I think that's something one has to keep in mind, especially also as teachers. The requirements change with age. And so it's always a question whether somebody can adapt to the new requirements. That's so finally, I wanted to, in principle, to study old languages. I was fascinated by Latin and Greek, and I was doing very well there. But I also was doing reasonably well in mathematics, chemistry, and physics. So that was a hard choice. Okay, I didn't have to choose modern languages. There I was, I would say, rather mediocre or even less than mediocre. So finally I had to make a decision what to do, and then probably out for some reason I choose the science direction and not the humanistic direction, and it seems I took the right choice. You see, you always have to make decisions. Even as a scientist, you have to make daily decisions. Not everything is proven. You see, if you could reduce it simply to certain schemes, then it wouldn't be decisions. And I think that's nowadays is forgotten, because especially politicians, they always want to have a very solid, to the point of the eye, scientific confirmation of what they think. And that's nothing but evading the courage of having to make decisions. So I think that's something very important, that children, that the young people learn. Life consists not of just being able to deduce everything, but of having to make decisions, stick out the neck for decisions. There is no way around that. Thank you.
Thank you very much. First, let me tell you that I'm very, very happy to be with teachers, because, you know, I've always taught in my life, first at the University of Paris, from 64 to 73, then at the Collège de France. I will tell you a few words about Collège de France later on. My wife, Jacqueline, is also a high school teacher in physics and chemistry. My sister is high school teacher in French literature. So I'm always lived in a teacher atmosphere. And I think it's a wonderful job. You know, I think I still remember my teacher in primary school, in secondary school, in high school. It's very important to find good teachers, because they determine your vocation. You know, as Professor Rohrer, I was also, when I was young, starting with classical studies, Greek, Latin, and I'm very happy to have done that, because it gives you an opening of mind, that culture is very important. Then, you know, in France, we have a French system. In addition to the universities, we have what we call grandes écoles. In university, we have no selection at the entrance, so that raises a lot of problems. But in parallel with university, we have this grandes écoles system where you have very difficult competition for being admitted. Examples of grandes écoles are École Polytechnique, École Centrale, École Normale Supérieure, preparing to various type of career, scientific research, teaching, engineers, chemistry, in all fields. So after my high school studies, I was in Algeria at that time when it was part of France before the independence. It was exactly the French system of education. I came to Paris to enter École Normale, where I spent 4 years, and then I found the best mathematician in the world, Henri Cartan, Laurent Schwartz, fantastic people. So I was initially more attracted by mathematics. But then I had also lectures from Alfred Kastler, who was a physicist who won the Nobel Prize in 1966. But he was also a poet. He was writing poems. And he has a way of presenting physics in a poetic way. It was so exciting that I decided to change my mind and to do physics. So I think it's extremely important to have professors who are able to transmit their passion for knowledge. It's exactly the good word. You see people who are inspired and who are really trying to give you envy to do like them and to continue in this line. And was explaining things in a very simple way, but also in a very elegant way. I think the beauty is also very important. Aesthetics of the idea is also an extremely important thing. And he was very keen with the students, and so I consider that I've been exceptionally lucky to be introduced to research by a personality like him. And also, let me tell you something which really impressed me, and which is very important. You know, when I was at École Normale, I was following lecture of mathematics at the Sorbonne. And Alfred Kastler was sitting among the students. He was already very well known, very prestigious. And he was wanting to learn mathematics because he thought he didn't know enough mathematics for it. So he had to train himself and to learn something. And I retained the lesson. You know, I think in our job of researchers, we are students forever. This is what I like, the idea of all life learning. Because, you know, a researcher has always to improve himself, to learn new language, new technologies, new concepts. And that was very impressive to see a professor like that, very prestigious, sitting among the students for learning. And I retained the lesson. I think it's very important, you know, when you understand something in research, you have many new problems to solve than before. You know, every discovery opens a lot of new questions, a lot of new horizons. So this is what's exciting in research. You are never doing the same thing. You have always to find something new and to learn something new. So I think the role of a teacher is extremely important. First, to raise the vocation, to excite a young student to learn, to improve himself, and to discover new questions, new horizons. And also, as Pedro mentioned before, I think science education are the best way for avoiding, you know, selfishness, fundamentalism, intolerance. Because when you are doing science, you know that you must accept, you must develop a dialogue with other people. You have to respect each other. And there is no absolute truth. You have to question always what you are doing and try to respect the opinions of other people, not to impose some ideas. So I think that the role of a teacher is extremely important, especially now, because unfortunately in all countries, we see that a decrease of the number of students engaged in science and technology, and that's a very bad situation, because I think that for solving all the problems of energy, environment, food, health, we have to do more science, and we need more scientists. And our role is to try to show to the young people that science is fantastic adventure, and it's better to do science than to do some career where you earn a lot of money. That the beauty of science is that you improve yourself and you contribute to the welfare of mankind. Thank you.
I much admire the remarks we've just heard from two fine teachers. I also think of myself as a perpetual student for the reasons that you have explained so well. If you're doing research, you keep finding new things. You keep moving on to the point where you are clearly incompetent and ignorant. And I like to say that, at least for my part, I've always been an amateur scientist, even though, amazingly, I get paid, which is nice, but I don't think of myself as ever quite a professional. An amateur, for me, means someone who makes up for lack of previous expertise and all by enthusiasm and excitement about the subject and eagerness to learn enough about it to see if you can contribute something value added to the field. And, so as your work unrolls, it just naturally points to new questions that you would like to explore, new things you can learn about. But all my life I have benefited enormously from teachers. I remember, for example, still vividly, my 4th grade in elementary school, Mrs. Davidson. She was extremely enthusiastic about the California Indians. I lived in California. Now, I don't know how many of you know something about the lifestyle of the California Indians. They're not a very exciting group of Indians compared with all the ones you hear about in the stories and the movies and so forth. The climate in California was very nice, so they didn't have to be very inventive. They could have very simple housing arrangements. Their food, they just ground in little stones, a small indentation. But somehow, Mrs. Davidson was fascinated by California Indians. So she had each of her students do a project of their own choice that somehow or other was to be related to something they looked into on their own initiative to find out about an aspect of California Indian life that got them interested. So that was, I realized in retrospect, my first experience was research, where I was responsible as, a 9-year-old kid or 10-year-old kid to make a decision, which was a good thing to start, about something I would want to do for my own project and read what I could and find out about it. What I wound up doing was building a nice little model cart of what the Indians had. So I had to make wheels and no nails or anything, of course, to put it together. And it was very, very lovely, very proud. I felt I'd done something. So that already was a beautiful experience due to experience with teacher. Now, I was also a farm boy. My family had very modest means. We didn't even know anyone who had graduated from college, for example. I didn't expect to go to college. But in high school, I discovered how exciting it was to learn things, and I was a very good student, but also a good football player of the American variety. You know, they play with a funny-shaped ball there. And so halfway through high school, my coaches were saying, of course you're going to college to play football. And in fact, later, I got admitted by telegrams from about 20 colleges, and the telegrams all came from football coaches. I had not applied to most of those colleges, but I got an athletic scholarship to Stanford University, but I turned it down because I also got an academic scholarship to Stanford, and of course it totally transformed my life entirely. In high school and college, I had some wonderful teachers. The most amazing was a Hungarian mathematician, Polya. And because of him, I became a math major, even though I had, because of a high school teacher, started out as a major in chemistry, and I continued it because I loved chemistry already, and yet Polya was so fascinating, and I saw that mathematics was so fundamental, and there are many opportunities to use it, of course, in all of science, that I knew, although I would later want to study chemistry further, I would like to major as an undergraduate in mathematics. That was especially because there were other Hungarian mathematicians at Stanford, and I had drawn the obvious conclusion after taking a couple of courses from Polya that I should never miss taking a course from a Hungarian mathematician of any kind. And that theorem held up pretty well in my experience. But what was so marvelous about Polya, unlike my previous experience in mathematics, which I had enjoyed enough, Polya never started by giving the theorem and then the proof and so on. He would give some concrete example that got your interest aroused. And then he would challenge you to guess what theorem or what principle might emerge from it. And that was an approach I loved very much. He also said so many little wise side remarks that I have repeated over and over to my own students. For example, I think it's important for research students especially, but everybody, to understand Polya's mushroom theorem, I call it. He said one day, after working with this problem, he said, when in mathematics you solve a problem, look around. You will find there are other related problems, which with probably a little adjustment or development, you will find you've also solved. And some of those may be more significant than the one you were working on to begin with. He said, it's just like looking for mushrooms. If you find a mushroom in the woods, you know there are more mushrooms nearby. Because in the nature of things, mushrooms don't grow all alone somewhere. The conditions are always such that there will be mushrooms nearby. So I thought that's the kind of lesson that remains in a student's mind. So my personal experience from teaching and learning from wonderful teachers is that, as you heard from Claude, the most important thing is to excite the interest of the student. What I think we really want to do as teachers is to catalyze, that's the chemistry phrase, but it's an appropriate one, to catalyze the development of the student so that they take ownership of the subject. It becomes something they recognize they actually can do and they want to do. If that we can achieve, then you can't stop them. They will learn so much, even despite the challenge that Pedro has emphasized, the rapid growth of knowledge and all. There are various kinds of knowledge, and some are more important than others. The most important is a kind of knowledge that is, I think, the best overall product of education, namely developing in the student the habit of self-generated questioning and thinking on their own, not just accepting what they're told or presented and so on. That's really the essence of what is called liberal arts education. Science should be like other so-called liberal arts subjects, history and all. Science should be very good in reinforcing and fostering that development in students, because, as you said so well, you have to question everything in science. It has to become a habit. Many people think of science as something where scientists carry a lot of pens in their pocket. I haven't checked to see whether you have any. And they know exactly what they're doing and so on. But actually, of course, that's not the case at all. We are very aware of how uncertain lots of things are, especially, of course, the frontier of developing fields. So it's almost more of an artistic thing. The reason I like to ask my students to write poems, that Pedro mentioned, is that I have to point out to them that in college courses as well as high school, most of the kinds of problems given in the textbook for the students are very unsatisfactory. First, the problem is stated in a way that you are given just what you need to know, nothing more, nothing less, and carefully set in a context where you're supposed to recognize, oh yes, we use this equation or this approach or whatever. But that's totally unrealistic. Even the students must recognize that very seldom does a doctor have a patient come in and tell exactly what you know, nothing else, nothing less, and so on. The same in science or many aspects of our ordinary life. You have to think for yourself and recognize things, make judgments and decisions all the time. And that's the fundamental thing we want to help our students develop capacity to do. And the other thing is that so often the way science appears to students is if it's a body of dogma or gospel that they have to master for the purpose of examinations and all. There's not much scope for individual imagination the way it is in a creative writing course or even in writing essays in history or other subjects. And of course that's completely unlike real science. There's a great premium in actual frontier research for bringing up fresh points of view. And actually you're not worried in pursuing a new research problem about getting the right answer, because after all, no one knows the right answer yet. So you're not focused on doing that. You are instead focused on, gee, do I have an interesting approach that seems to offer an opportunity for a fresh perspective? And of course the poem is immediately something where there's no question of right or wrong. The question is instead whether your topic is an ordinary kind of thing or some exotic thing, whether you bring an interesting perspective to it, a fresh way of looking at it in a way that's your own. So those are some observations from my life and perspective on teaching. Thank you.
Ahora, con los estudiantes solemos hacer, ellos han trabajado durante meses o semanas y las preguntas vienen escritas y hacemos un sorteo, pero aquí vamos a hacerlo con un coloquio de amigos. No sé cuándo pararemos para el café, si seguimos. Esto es un coloquio de amigos, o sea que adelante. A ver quién dispara. ¿Quién toma la decisión de ser el primero?
Hola, buenos días. Voy a hablar en castellano. Thank you very much for your interesting talk and experiences. And I am going to speak in Spanish because it's my first language. Gracias por estar aquí. Gracias, Pedro Miguel, por darnos esta oportunidad de compartir con estas personas sus experiencias. Y bueno, yo quería hacer una primera pregunta, aprovechando algunas de las aportaciones que han hecho cada uno de los profesores. Se ha hablado de la ciencia en contexto, es decir, problemas que sean interesantes, interesar a los estudiantes. Se ha hablado también de la ciencia en toma de decisiones, en posibilitar a los estudiantes que tomen decisiones fundadas no en creencias y en fundamentalismos, sino en la forma de trabajar la ciencia. Bien, mi pregunta es cómo superar el gap que existe entre los currículos actuales de ciencias en la escuela, que están llenos de conceptos, leyes y principios, y que están a falta de ejemplos que contextualicen esa ciencia para hacerla interesantes para nuestros estudiantes. ¿Cómo podemos impulsar ese tipo de materiales o ese tipo de acciones que nos lleven a poder superar el gap que yo veo entre lo que ustedes nos ofrecen y estamos viviendo aquí estos días en Passion for Knowledge y los currículums muchas veces totalmente descontextualizados que solo ofertan a nuestros estudiantes matemáticas, leyes y principios? Thank you very much.
Who wants to begin? Claude?
Yes, you're right. Perhaps our programs are not enough oriented towards questioning, inquiry. And perhaps I would like to mention a few experiments, teaching experiments all over the world, which start at the primary school level. And I don't know if they're in Spain, experiment of this type. It's called la main à la pâte, hands in pasta. You know, the idea is to take the young children at the age of 4 or 5 and to present them very simple things, very simple experiments with cheap equipment, just to develop the sense of observation, the critical mind, what they observe, how can they explain what they observe, and with the help, of course, of the teacher, and trying to make some assumptions. That probably the reason for this to happen is this and this and this, and they can try to make some simple test of their ideas. So I think developing the critical mind, the sense of observation, the questioning, the what sort of inquiry, in English it's called inquiry-based science education. I think it's important, and I think one should keep this philosophy all over the classes of a student. Try to present things, observation, results, and try to develop questioning. What is behind? How can I explain this? What could be done to test this explanation? And I think this way of teaching, I think it's important. It's not dogmatic. It's not just learning by heart some equation, some formula. Trying to see what is behind this equation. What are the physical processes which are hidden in this abstract equation? And I think one should try to develop this kind of teaching. I think that's very important. And apparently it's very successful in the class where it works. It's very successful because also children coming from different cultural media, or education, or families, and you know, science is a universal language, and they get together, and that perhaps tends to decrease the difference of situation of wealthiness in the different families. And the problem, of course, is to train the teacher to make this kind of teaching, because most of them are afraid. But you know, I think it's important also for a student, for young children, to see that the teacher doesn't know. He like him, he has to ask the question. And you know, everybody has to question himself and to try to understand. So perhaps to reduce the gap that you are mentioning, one should try to develop this kind of pedagogy. It's not easy, but I think it's worthwhile.
Heinrich, would you like to comment on that? Would you like to answer the question, or Dudley?
Yeah. I have also had the pleasure of taking part in programs like you described for fourth grade students. One that comes to mind that was a very lovely experience was magnetism. It's intrinsically fascinating to kids. You hand out magnets to all the kids and let them start by just finding out what is magnetic around the room. And then they have some iron filings, and they can they can discover for themselves the field lines that are generated and draw pictures and so on. Then you pass out some bolts and some copper wire, and they wrap various numbers. They can choose their own numbers, coils of the wire, and then you do various little experiments with these coils they've made that actually, you don't use any equations, of course, actually give Faraday's experiments that were the basis that Maxwell translated into those T-shirt equations and so on. And the fourth grade kids, are doing this and enjoying it and understanding it because they have to give their own observations and guess what they mean and how you might rationalize them and so on. So that is a very fine approach. In my teaching in college, I find that, again, if you can put it in, you describe a context, and I think the context needs to be what Claude mentioned, the background of physical understanding and all, but also the human context, so they understand it's part of the adventure of our species. If they understand that, they already may feel some urge, maybe this is something I want to take part in. So I've come to teach by what I call the method of parables. I think there's empirical evidence that parables are a good teaching method, because if people are repeating a parable 2,000 years later, it must have conveyed something valuable to their thinking and framework. In fact, I think you can say that a culture is tied together by parables, shared parables, stories in people's minds that give them a common basis of reference, of ideas and understandings. And, for example, one thing I did early on, and I've done a lot of these parables, many of you, if you teach chemistry, you have to talk about at some point the gas laws. Well, of course, you need to do that. So I always walk up and I point to some student without saying anything, except today we're supposed to talk about the gas laws. And I point to the student. And after a while, the student realizes what they should say. I haven't asked them what to say. I'm guessing you know about the gas laws. So what comes to mind? Usually the student, after a silence, says sort of timidly, PV equals NRT? And I say, well, yeah, but what about VP equals NRT? Isn't that okay too? And so I start teasing them a little bit. And then I say, that equation is very handy, very useful. We'll play with it. And you can see it just relates four things in a useful way. But it doesn't give you any idea of the wonderful background for this. So then I say, let's start with Aristotle, 2,000 years ago, with a water pump. And I asked them how many have seen this kind of, I would show a slide of an Amish girl. They don't use electricity. So the kind of water pump I mean? This is called what? Most people call it a suction pump. That's what Aristotle called it. He discussed it in his physics. It's been used back then. It's still used over half of the world. Still pump their water that way. That nature abhors a vacuum. So that's when you push the lever, you create a low-quality vacuum. And nature abhors it. That's why the water comes in and shuts out. But we know, even in Aristotle's time, those pumps don't pump water more than 34 feet. About 10 meters. Aristotle didn't seem to feel he needed to explain that exception. So already it teaches you something different between science and philosophy, right? A scientist would have to say, whoops, this doesn't pump more than 34 feet. How come nature stops abhorring a vacuum after 10 meters? And so you get the question, the students think about this question right away. And then you say, well, let's see what Galileo said about it. And his two new sciences, way after Aristotle, in 1638, Galileo discussed it specifically because he'd been asked about it. He got it wrong too. He had in two new sciences said that he thought it was maybe because a column of water more than 10 meters would break of its own weight. Then you ask students to think about if they've seen. Okay. Well, actually, the problem was solved by a student of Galileo's. That's why I like this story. Just as some of you students are going to solve problems that your professors couldn't do. The student was named Torricelli, and he took seriously something that Galileo had said in the same Two New Sciences book, but Galileo had not thought of it quite far enough. Galileo had spoken of invisible corpuscles in the air, and he'd done an experiment. He'd taken a leather bag, collected some, sealed it, weighed it, flattened the bag, weighed it again. What was wrong with that experiment? He concluded that those corpuscles didn't weigh enough to worry about. Now, evidently, Torricelli must have thought, well, wait, maybe these corpuscles went up very, very high, so maybe they do weigh something and press down. So he thought of an experiment. Of course, you all know the experiment. He took a tube, only about this long, meter long or so, with mercury. Much easier to handle because it's 14 times more dense than water, so you don't have to handle a 10-meter long tube, and you know his experiment. And, of course, he did it, and it raised to a certain level. It was really weighing the pressure from the air. There was a vacuum at the top. It was called the Torricellian vacuum. And scholars wrote many papers explaining how there must be invisible threads holding up the mercury, because Aristotle had said nature abhors a vacuum. So it was a great experiment. It destroyed this totally wrong idea that had existed for 2,000 years. It gave an instrument you could carry, and people soon did, up mountains, find pressure dropping. Before long, people made little better vacuums, and they found, if you had a clock in there, you couldn't hear it. If you had a mouse in there, it died. On and on. Lots of things developed from first vacuum. So all of that is hidden in publiko NRT, which is an impoverished thing. So if you set it in this sort of context, so the power of stories, I advocate very much in teaching science and anything else. Teaching it in a humanistic mode, where in humanities courses there are usually lots of discussion because they think that way. We don't do enough in the sciences to open it up. Anyway, that's my general suggestion.
I agree with you that we have very strange curricula, especially in high school. But we shouldn't forget that we have to structure our experience in one way or in another. And I think that's acquiring knowledge. And we have to acquire knowledge which we might not know as a student at the moment. What is it used for? But eventually he will use it. We cannot learn all these things just when we treat the problem, whatever is needed to solve this problem. That's, I think, one thing. Acquiring knowledge is simply necessary. Even if you don't always know why you have to acquire this knowledge at this moment, because you have to build it up on a reasonable structure. That's one thing. And the other one is, if I looked at the textbooks of our daughters in high school, I must admit I didn't know what the textbook were meant for. And I think that's one of the problems. In high school, you have to convey, let's say, the ideas of physics or the ideas of chemistry. You have to teach in a way that might be which might be used when you go to university by more or less everybody, you see. But unfortunately, we do mathematics in terms of preparing the high school students for a mathematics studium, and not for a general, general knowledge of mathematics, which will be in one way or in another used by a medical doctor when he has to learn physics, or used by an economist and so on. So we have to rethink the knowledge we want to convey to high school students according to what the majority of them or will use or is necessary for them to know. But we should not train our high school students in mathematics according to later study of mathematics or physics for preparing our high school students for a physics career and so on. So I think there is a lot of room. For instance, on the high school, I just take now the high school level, a lot of room on the high school level to rethink whom do we really want to teach what, you see. And that you keep it on a level which is useful for everybody, and whoever wants to then specialize in the university career, he will do it in any case in a on a higher level. But I think you are absolutely right. We have to rethink the high school level. We also have to rethink the undergraduate university level. What do we really want to teach, and what is really necessary to make a career in this way or in this field or in this field.
Otro comentario, pregunta. Si queréis hacerle a uno en concreto, indicar o lo que queráis.
No. Bien, yo creo que tengo que agradecer también a las personas y las organizaciones que han propiciado esta reunión. Para mí es un privilegio estar aquí con personas que están hablando de aspectos muy básicos de la enseñanza media, realmente, y que por otra parte son investigadores de talla. Entonces esto de descender a la arena es algo muy difícil, en general, para muchos investigadores. Estoy observando que la mayoría del debate está situado en ese nivel básico de enseñanza, de la enseñanza media. Yo soy profesor de universidad y lo que me queda más cerca es la enseñanza de la universidad, no la básica. Entonces, quería tocar un tema a este nivel de la enseñanza en la universidad, y es que la tendencia actual en la universidad es, yo diría de una manera así como muy sintética, que nos pagan por enseñar, pero nos promocionan por investigar. Entonces eso conlleva en el profesor de universidad, teóricamente debería ser un profesor investigador, pero toda la evolución de la enseñanza y realmente las nuevas tendencias de Bolonia van a dedicar cada vez más tiempo al alumno a todo lo que es el aspecto de educación. y de alguna manera la gente se va a sentir penalizada en su tiempo y demás para hacer currículum investigador, que en definitiva es cuántos artículos científicos, cuántos papers al mayor factor de impacto. O sea, ahí está el kit de la promoción de la persona. Entonces, el profesor de la universidad se encuentra una dicotomía en el tiempo de cómo hacer esta enseñanza, de dedicar tiempo a los profesores, a los alumnos, con otros profesores, hacer reuniones, hacer seminarios, etcétera, etcétera. Y por otra parte, tener un currículum competitivo que le permita a uno promocionarse adecuadamente. Y es una situación que yo creo que ahora se va a agravar más con Bolonia, que de alguna manera es pretender una enseñanza a la carta de cada alumno y a cada nivel. Y, lógicamente, la investigación va a sufrir. Hay profesores muy inquietos en la universidad con las nuevas tendencias que se están refugiando, entre comillas, en institutos de investigación ligados a la universidad para, de alguna manera, alejarse de toda esta tendencia que va a haber de que el profesor se le va a exigir dedicarse más y más a la enseñanza en detrimento de la investigación.
Bueno, antes de dar la palabra, explicar que quizás yo agradezco mucho esta pregunta, pero quizás Dudley, Heinrich, estos, por ejemplo, yo personalmente casi no sé lo que es Bolonia. Dudley probablemente no sabe lo que es Bolonia. Yo formularía la pregunta, como él lo ha hecho en forma general, de cómo ven la compatibilidad entre una estructura que fomenta, que exige enseñanza, pero solo promociona por investigación, y luego va implícito en la pregunta una forma de evaluar la investigación que es por cantidad de artículos y por factores de impacto, que también eso es una forma, los indicadores son indicadores. Mi experiencia es que cuanto menos desarrollado científicamente el país, más importancia dan a los indicadores. Yo creo que nos sorprenderíamos saber que la mayor parte de los profesores de la Universidad Española tienen mucho más artículos de investigación que Heinrich Rohrer, muchos más, pero no es la... Y probablemente que Cohen, no creo que Cohen escriba muchos artículos, los químicos como Dudley. Quiero decir que la pregunta espléndida que os han hecho se refiere a una forma concreta de evaluar aquí, con la que muchos, por ejemplo, yo estamos en desacuerdo. But I'm sure that Claude, you want to comment about this?
But I agree with you that it's a very important question, and it's very often asked. And you know, it's a pity, because I deeply think that teaching and research are really strongly connected. I think it's very important when you are teaching to do research, because if you do research, your teaching will not be obsolete very fast. You know, you have to renew your inspiration by doing research. On the other way, if you are doing pure research without teaching, that's bad, because I think it's very important when you have understood something to try to explain to other people what you have understood. So I think that teaching is very important. And I was mentioning just in my first intervention the Collège de France in France. It's a very special institution where we have about 50 professors in all disciplines. You know, we have no students. Anybody can come and follow the lecture. We don't give any degree. But we have to teach every year a different course, a different set of lectures. That's extremely difficult, because the people who come to listen to your lectures are not coming for getting a degree. They are coming for learning something. So it's very challenging, and it takes a lot of work, but it's also extremely stimulating for research. I just say that for saying that research and teaching are two complementary activities. But I agree with you that there is a problem. And I think the way to solve it is to find some flexible structures, first to decrease the teaching duties, because I think when I was young professor in 1964, I had only 3 hours of teaching per week. I don't know what in the United States you can have something similar. Now it's nearly 3 times or 4 times more. And when you have too many lectures to give, then you can no longer do research. Obviously, with also the bureaucracy has increased dramatically. You have a lot of committees. You lose your time in discussion. So I think that can be improved. That could be improved. Also, I think that we should have some system where you teach during certain time, and when you have some interesting problem in research, you could have some temporary position in a pure research position for 3, 4, 4 years, where you could have much less teaching to do, and you can devote more time to research, and then come back to teaching. So I think we can find a system like that. For example, now in France, we have what's called Institut Universitaire de France, where a few professors their teaching reduced by factor 3 for 5 years. And during 5 years, they can do more research, and then they come back to teaching. So I think one could modulate in time the proportion of time spent to research and the proportion of time spent to teaching. And also, I think in the promotion, one should take into account the teaching activity, the books that you are writing, that could be important, because that's very important for the new generation. So I think you are raising a very important question. A lot of people are concerned with this question, a lot of complaints like yours, but I think there are solutions.
Okay, since I never was teaching, I cannot really comment on it. I just always wonder, I mean, you are the persons who tells you to do, and who determines the rules according to what you promote? I think it must be the professors. It's not some politician somewhere. I think we make that's one of the very strange aspects of science. We scientists, when we are in certain positions, we make the rules. I mean, all the rules which bother us, most of them are made by scientists when they get older or whatever it is, or when they get more powerful. On the committees, you see, where you hand in proposals, the nasty responses you get back for your proposals, for publishing, that's all scientists, you see. That's not somebody somewhere, you see. And so I wonder why. Why is it so? Just wondered. Now, about that, about the citation index and all these things. Let's say, if you get a new professor at Harvard, you don't care about his science index, because you have to know the guy. Your people, you have to know the person, and you determine on what you know what he did, and not on some citation index. I think that's just some way out of sneaking out of a responsibility. And about Bologna, okay, Bologna is simply a drive in Europe to put science on, let's say, to coordinate science, so that you can change easier from one school to the other. But take now the United States. I mean, the differences between the colleges in the United States, that's worlds in between, you see. And that's why also in the United States you want to treat everybody alike. I mean, you have so many lawyers who simply look for that. But a person for the PhD study in Harvard is not accepted on the grounds of his of his grades, he's accepted by personal interviews, more or less. I think a recommendation, and you make an interview, you see. He is always accepted on personal grounds and not on some unified grading through whole Europe. And I think that's one of the problems of the Bologna operation, you see. And I do not know what strange brain has thought up this whole Bologna, how would I say, I think I can't say bullshit. This whole Bologna confusion, you see, simply confusion.
I can't help but think of the statue of Albert Einstein we visited. He failed the entrance examinations to the Zurich Polytechnic. I won't go into the details. And he was able to get in a special way because he went to a school that automatically accepted him for 1 year and so on. So just, again, stories help. You can point out under the current rules, Einstein wouldn't have been allowed to go to college, and things like that help a bit. But one thing you might want to seriously think about is bringing the students in to help with the research. At Harvard, students are so eager at first year, just arrived, to do research. And more they are doing that. I mean, their programs just in recent years, and the faculty has discovered how even these students, have so much energy despite taking more courses and so forth than most graduate students and postdocs. They work so hard. They're so eager. And they learn from the graduate students a lot. So it just creates a wider community, a more free and unstructured community. Not a hierarchy so much that undergraduates only go to class and so on. So that actually has made a big difference for some young faculty members in terms of producing interesting research in collaboration with their students. But I agree very much with what Claude remarked about. It is a serious problem, and it is indeed up to scientists to try to take the lead in breaking this down. With respect to citations, I always think of a classic remark in 1911 by Arnold Sommerfeld at the first Solvay conference. Einstein had just given them an all-important paper showing that the key thing in understanding thermodynamic properties from the point of view of the new, just being born quantum idea was the ratio of the quantum of energy over kT, Boltzmann's constant times temperature. If you understood that, it gave a weighting to various kinds of motions, whereas in classical mechanics, they all got counted. So Sommerfeld said, Herr Einstein has taught us that we should not count, but weigh degrees of freedom. And that one sentence is the essence of the whole business of what we call quantum statistical mechanics, one sentence. But it should apply to assessing many things. You have to use judgment, not some mechanical counting system.
Ahora vamos a ir a tomar el café, pero aprovecho la oportunidad para agradecer las preguntas y el privilegio de ser moderador para intentar hacer algún comentario. El problema que tenemos es que nuestro sistema educativo es regulado y uniformizado por ley. No tiene la libertad del sistema educativo que ha triunfado en el mundo, que es el sistema anglosajón. Nuestra universidad está regulada por una burocracia excesiva. Yo lo suelo resumir que está sobreregulado e infrafinanciado. Pero la idea que se ha presentado aquí, cuando Dudley habla y Hein de cómo se selecciona el profesorado, Francia es un poco diferente. Luego comentaré el College de France, pero en Harvard, cuando es los profesores, porque ellos son la universidad. Pero aquí, ¿qué profesor se siente ciudadano de su universidad? Los catedráticos somos ciudadanos del Estado, que prácticamente no nos puede tocar nadie, hagamos bien o hagamos mal. Hay una anécdota preciosa cuando Eisenhower visitó Columbia. Rabbi, I think Rabbi, the famous physicist, he made a comment directed to Rabbi thanking the employees of the university, which Rabbi Nobel Prize corrected him. Mr. President, you are the employee, we are the university. So that's very important. Entonces, I also love the comments by Cohen-Tannoudji about the complementary of research and teaching, but I will go even further. It's not only complementary. In many cases, they are indistinguishable. When Cohen-Tannoudji or Heinrich or Herschbach talk to the students and discuss things, what they are doing, teaching or research. When they see a better way of teaching because of the research, what they are doing, teaching or research. When they find a new idea for research of their teaching, what they are doing. Una anécdota deliciosa es Fermi, que era un gran físico y obviamente un hombre de gran altura moral, le preguntó a un estudiante, ¿qué opina usted de este trabajo de tesis doctoral? Y le dijo, lo leyó y dijo, me parece excelente. Cuando llegó el examen, 6 meses después, este estudiante creyó que tenía la gran suerte de tener a Fermi en el tribunal. Y entonces Fermi fue demoledor y prácticamente aniquiló al estudiante, al contenido del estudiante, respetando a la persona del estudio, como era él, no al. Y entonces, sabiendo la altura moral de Fermi, el estudiante le preguntó, pero oiga, usted me dijo que esto estaba bien antes. Y Fermi contestó, sí, pero yo entonces no había explicado el curso de termodinámica. Eso cambió sus puntos de vista. El Collège de France es una institución maravillosa que no solo enseña a gente que quiere aprender. En Francia, nosotros hemos tenido el privilegio en el DIPC, y por eso aprovecho, como dice en la literatura, todo es bueno para el convento, de tener un curso del Collège de France con Jean-Marie en el DIPC, un día entero, diferente sistema, pero aprovecho para agradecerle a Claude también. El problema de fondo que tenemos, en mi opinión, en el sistema educativo es que muchos de los profesores tienen passion for knowledge, pero en Europa se está desarrollando passion for bureaucracy, ¿no? Que hay que tener un máster en burocracia para a veces entender. Pero esto es otro lío y yo creo que ahora lo podemos discutir mano a mano en el café. Now we go for coffee, you discuss informally and come back for the questions. I will ask the questions to be short, and I dare to ask these eminent people also the answers to be short, because there are so many people who want to ask questions. I hope that otherwise we don't have lunch. And I know Heini and Claude want to have lunch, although Herschbach wants to prepare his talk even more. That's also a signal of a great teacher. They all have given talks and talks and talks, and they could not prepare the talks, but they are going, all of them, to prepare for the 10th time the talk of this afternoon. That will be superb, and I, of course, ask you to go, because the 3 of them I have listened many times, and every time I listen to them, I don't come out saying, I didn't understand anything, because it has been such a great talk, very elevated. On the contrary, with all of them, you will go happy outside, because you will have understood all. Seguimos ya ahora con las preguntas y respuestas. Yo me he tomado la libertad de pedirles que, a pesar de que tienen tanto que decir, intenten ser lo más breve posibles en las respuestas, porque tenemos solo, el tiempo vuela, bueno, no solo, tenemos 1 hora, pero que es poco para la gran pasión por preguntar que he detectado en el café. Passion for questions. He detectado en el café, y oso a vosotros pediros, insisto que puede sonar a impertinencia, encima que habéis venido, nos habéis ayudado, estamos encantados de teneros, breve, pero dentro de un orden, claro. Venga. Marifé.
Muchas gracias. Bueno, gracias por esta posibilidad. Gracias a Pedro, que tuve la suerte de que fuera mi profesor en la Facultad de Químicas.
No estaba preparado esto.
Pues sí, me dio la asignatura de mecánica en segundo. Tuvimos una fuerte formación en física, a pesar de ser químicos, cosa que me pareció buena de cara a la interdisciplinaridad de la que hablamos. Y bueno, me acordaba yo de una anécdota en sus clases. Le comentaba a Pedro que me gustó de él y recordaba de él como profesor que no se atenía al currículum como muchos, que era un poco más filosofía de la ciencia y que era muy interesante, porque eso queda más que las ecuaciones y más que otras cosas. Y una anécdota me acuerdo que nos dijo una vez que escribiríamos en un papel si tuviéramos que escribir solo una cosa para dejar a las generaciones posteriores, lo que considerábamos lo más importante. Y nos dejó pensar durante un rato largo. Yo no recuerdo lo que puse yo recuerdo lo que nos dijo él que
es de Feynman, no mía.
Ah, bueno.
Bueno, la respuesta es de Feynman.
Sí, o sea que te acuerdas. Bueno, el caso es que nos dijo que él dejaría para las generaciones posteriores el hecho de que la estructura atómica es la base de la materia y la explicación del átomo. Y aquello me marcó de alguna forma pues que para él era la primacía de la ciencia en ese momento, ¿no? Lo que podíamos dejar a la generación posterior. Y me parece que como estudiante esas pequeñas cuestiones son más importantes a veces que ciertas ecuaciones matemáticas, ¿no? Y yo como profesora ahora de física química en bachillerato quería saber un poco en este momento que andamos con las competencias para hacer competentes a nuestros alumnos. Me gustaría hacer futuros posibles científicos competentes. Y me gustaría saber qué opinan ustedes de cómo podríamos hacerlos competentes a nuestro nivel en bachillerato. ¿A qué deberíamos dar más importancia? Y si también la ética debería ser otra competencia importante a formar y qué en sus investigaciones, qué momentos han encontrado en que la ética ha sido fundamental para seguir un camino u otro o para cerrar ciertos caminos o no, o si es de verdad también importante a nuestros alumnos transmitirles algo en este sentido. Y también, hablando antes ustedes de que era importante como profesores seguir siendo alumnos, yo he descubierto en mis clases que los alumnos también quieren ser un poco profesores. El otro día, proponiendo trabajos, uno me dijo, ¿puedo hacer un trabajo sobre agujeros negros? Que me apasiona. No tiene que ver con la asignatura de este año, con el currículum, pero puedo. Y, por supuesto, le había apasionado, precisamente pasión, por el tema. Le dije, cuéntanos lo que sepas con diapositivas. Bueno, él se apasionó explicando y nos apasionó a todos. Toda la clase ha acabado preguntándole sobre el tema. Yo creo que en ese momento él se sintió diferente, se sintió profesor dentro del ser alumno, despertó la pasión en los demás y creo que eso es fundamental. Y bueno, y termino la pregunta que me extendió un poco. Muchas gracias.
We begin with Heinrich this time, no? Heinrich, you want to be the first or Dudley the first?
I'm delighted by what you just said. This is called peer instruction now. It's very popular in education ideas, and it seems to me perfect if you invite students to suggest things they want to do, just like my fourth grade teacher, Mrs. Davidson, that I told you about. But this is even better if the students have the freedom to pick their topic. For 7 years, I've taught a freshman seminar now. Just 12 students meet 2 hours a week. And we operate that way. The students choose topics of papers they write for each other. They work very hard. Why? Not, I think, because they want to impress me. I think they want to impress their fellow students. And they would be embarrassed not to do as well as the other students do in working. Einstein said that love is a better teacher than duty. He was referring to why he never practiced the violin until after he took lessons. He never practiced when he was supposed to, but when he stopped lessons, then he'd fallen in love with Mozart, so he started practicing his violin. So,
I think you're right. Excitement is the best thing. Students should be excited to learn something, but also one should not forget also that you have to teach the basic things. We have to make a clever combination of excitement by new things and also the teaching of the basics. Because unfortunately the programs are shortened more and more and we have less and less time for teaching the basic things.
I think I have nothing to add.
Bueno, la cita de ella que yo recuerdo, Feynman en las lecciones de física se pregunta si hubiese un cataclismo mundial y solo se pudiese trasladar a las generaciones siguientes una frase. ¿Qué frase contendría la máxima información en el menor número de palabras? Y esa es la pregunta que yo les hice. La respuesta de Feynman es la hipótesis atómica, que todas las cosas están hechas de átomos, partículas que cuando se alejan unas de otras se atraen, pero si se les acerca demasiado se repelen. Y eso es una pregunta que... otra pregunta que a mí me suele gustar, yo les voy a hacer la pregunta a los tres ponentes aquí. Si tuviesen que elegir dos palabras para resumir la ciencia del siglo XX, ¿qué elegirían? Dos palabras para resumir la ciencia del siglo XX. O we leave this question for later and we continue. But then at the end we will close with these questions. 2 words to summarize the science of 20th century. The science that of the matter that matters, that Len said yesterday, not the black holes. But later. I'm sorry. The ethics question. Do you think...
The ethics question, I think, again, that's something you can probably best handle by telling stories, by making the students aware of situations that these stories deal with. I think that's most of the way we would learn about ethics in humanities courses, for example. So my basic view is we should try to teach science more in the mode of humanities, and vice versa, as a matter of fact. I think that because we teach science and math and only in separate courses, we reinforce the idea it's not part of our culture. We have to integrate it with other topics, and I think we could do that. But that would take a little longer to explain.
I think they all agree that ethics is very important, but that's what she's asking, not about the way to... Anyway, we all agree. Ethics is very important.
I certainly agree. It's terribly important. I mean, science has to be honest above all. Unless you can trust what other scientists say, then it collapses completely.
Okay, next question, please. The theory of everything.
Yo relacionado sobre el problema de las vocaciones científicas, salía en un curso que hace poco en los cursos de verano sobre comunicación de la ciencia el problema o la importancia de revalorizar la imagen de la ciencia y del científico en la sociedad. Y entonces, bueno, quería plantear un poco si esto es responsabilidad de los profesores en la educación secundaria, si es culpa o responsabilidad de los científicos. ¿Qué podemos hacer desde la educación secundaria, desde la escuela, para que revalorizar la imagen de la ciencia y de los científicos hacia los jóvenes?
Yes, of course, it's a responsibility of the teachers to improve the image of science. But I think also the media should have an important role in that. And unfortunately, I don't know they are not devoting enough effort to make science attractive and understandable. Most of the emissions devoted to science are very poor, at least in France. I mean.
I'm very often asked in Japan to give lectures to the public. And one of their major themes goes along, they have a very long title, what do we have to do to raise creative children? And to me, we have a little bit the same question. What should we do to get young people interested in science? And I think in both cases, you have to avoid to destroy the creativity. Children are per se creative, very creative, and along the way we, let's say, this creativity gets destroyed to some extent by the others. And I think also in science, I think you have to be careful that you don't take their courage to enter into science, to engage into science. I'm sure a lot of young children are fascinated by science, maybe not in the terms of science they do at that time or they understand it. But I think it's very important that you do not really kill off this love for science.
I totally agree. One thing that kills them off is sending them to school. Every kid is born a scientist because of their great curiosity and an artist. They all want to express themselves, painting paintings and on. Then they go to school, it's quenched. I think a major reason is examinations, especially for science and math. Many students of Harvard have told me they turned away from science because the first thing they met was only one right answer, and they weren't confident they could do it, so they avoided. And we have to think about that. There should be ways to ameliorate that. I think that's really a very fundamental problem.
Of course, I just mentioned in my first answer the program like hands-on or la main à la pâte, that you can keep this creativity by finding new teaching methods, a new way of approaching science and observation. And also museums also would be extremely important. Yeah. Having children going to museums and watching some simple experiments and discovering a lot of exciting things. So I don't agree that going to school destroys the creativity. Well, if you have good programs and good,
meant going to school
programs,
as it usually done.
Yeah.
I totally agree with you. I think that's exactly the way to do it.
Una pregunta también, además de lo que han contestado, la pregunta tiene el componente de la imagen del científico a la sociedad. Muchas veces la imagen que se proyecta del científico es una persona extraña, rara. ¿Qué película hemos visto últimamente que trate de la vida de un científico? Una mente maravillosa de Nash, ¿no? Es un hombre ejemplar, igual maravilloso, pero ¿quién querría ser como Nash? ¿Esa imagen favorece a la ciencia o no? No es, mientras que vemos en la televisión series en que los médicos son maravillosos, a veces son un poco impertinentes, como el Dr. House, pero ayuda a salvar vidas. Los abogados son fascinantes, tienen una vida dura, maravillosa, pero la imagen de la ciencia que se proyecta en los medios, ¿qué os parece? ¿Cómo es? ¿Qué imagen se proyecta? ¿Cómo veis vosotros? Por supuesto, esta vez le voy a ceder la palabra para que empiece al profesor Herschbach, que creo que es el único científico que ha aparecido en Los Simpsons. Él tiene la tarjeta de Los Simpsons y que le ha producido, como él me dijo una vez, 100 veces o 1000 veces más fama que el premio Nobel.
Well, it came about because I taught freshman chemistry, and one of my students eventually became on the staff of The Simpsons. And I guess he had, without my knowing it, or he knowing it at the time, he was auditioning me for my voice over the whole course. At any rate, you know, you're just a guest voice. Only your voice appears. They make cartoons. And it was an interesting experience to do it. But it does help, I think. I got an amazing number of emails from people, even someone in the Department of Defense, saying how wonderful it was for the stature of science that appeared in The Simpsons. I've met groups of, say, Middle Eastern students, Israelis as well as Arabs, all in a group. First thing they want to ask about is The Simpsons. So I guess you've struck something. If we could get more on The Simpsons, maybe it could happen. I'm glad to call up my former students and suggest that
Cohen.
interview you in particular.
Thank you very much. Heinrich, you want to comment on the image of the scientist or not?
No.
No. Thank you.
Sí, yo quería hacer un comentario a cuenta de lo que estáis ahora hablando de la creatividad en los centros de enseñanza y cómo va disminuyendo a lo largo de la escolarización de nuestro alumnado. Es cierto que antes hemos empezado el debate con una pregunta de Genaro, los currículos sobrecargados de contenidos conceptuales. La reforma de los currículos que ha habido precisamente ahora trata de evitar eso. Se habla de un trabajo por competencias, donde lo importante es el contexto, que se ha hecho tanta importancia aquí, el saber hacer más que el saber a secas, saber pero para saber hacer algo. Y todo eso en secundaria se le está dando y se está trabajando muchísimo en ello. Hay cantidad de investigación que ha demostrado que efectivamente el interés del alumnado por la ciencia disminuye a medida que aumentan los años de escolarización. De manera que en primaria tienen muchísimo interés por la ciencia y cuando llegan al final de secundaria es mínima y por eso tenemos tan pocos alumnos que estudian ciencias en bachillerato y tan pocos alumnos que quieren cursar carreras científicas. Esto es preocupante, lo han mencionado todos los ponentes. Está el informe Rohrer, habla del enorme problema que va a tener Europa por la falta de científicos y hace recomendaciones a los estados, ¿no? A los estados. Pero hay una importante. Lo importante es no solamente dar más importancia a la educación científica, sino cambiar los métodos en cómo se enseña la ciencia. Yo creo que ahí en los centros de secundaria se está haciendo un esfuerzo muy fuerte, pero quizá, desde mi punto de vista, cuando se llega a bachillerato, todos esos esfuerzos que se hacen en secundaria y en primaria se paran porque detrás tenemos la universidad, tenemos la selectividad y sigue pesando como una espada de Damocles que se repite en todos los foros, pero que sigue estando presente. El profesor Cohen ha nombrado, por ejemplo, que en Francia trabajan con proyectos como Element de Lepate. Aquí hay centros que ya lo han puesto en marcha porque se han programado proyectos de ese centro. Si hay propuestas para trabajar proyectos ingleses que trabajan la biología y la ética o la física y la ética, cantidad de proyectos de ese tipo. En secundaria se están haciendo muchas cosas de ese tipo. El problema es que nos falta unificar esfuerzos entre centros de secundaria y bachillerato. Y me gustaría que y universidad. Y me gustaría que todos ustedes como profesores, además de investigadores, profesores de universidad, pues comenten esto. Muchísimas gracias.
You are perfectly right. There's a lot of work to be done. For example, unfortunately, most of the time, for example, the time devoted to science in the programs is decreasing, continuously decreasing. And of course, we would need more time to explain the basics of science, how it is interesting, how it is passionate, to devote more time to practical work, to handle some experimental. So I think our duty is to inform the politicians that they are going the wrong way. Instead of reducing the number of hours devoted to science in the program, we should increase them and make science more attractive. And that's a collective effort to be done.
I hear about this science students, the number declining now. In Switzerland, it is rapidly increasing. I think the last 3 years showed a remarkable increase in students in science and engineering. I don't know whether this is simply a matter of the crisis we are going through or not, but I don't understand it when I hear that in other places the number of science students is decreasing. Back home it is increasing.
It is a very serious problem and you hear about it everywhere. I wonder if one approach would be to look for what are called positive deviants. Anytime you have a general overall problem, you will find in a broad society that there are exceptions, and the so-called positive deviants. And they're especially important because if you understand how they came to be deviants, and if you make other people aware that these people with the same sort of background, usually similar resources and so on, have solved this problem locally, then there's a chance the culture can take it on. I mention this because I know people who work for Save the Children, and they have developed a course in positive deviance. They had experience in two areas particularly. One, they first served in Vietnam at a time that there was endemic malnutrition through the whole country of children. And then they found in some of the villages there were exceptions in certain families. And they found out the mothers, usually the mothers, actually were supplementing the rice diet of the children with little shrimps and greens that most people thought, oh no, that wouldn't be suitable for children. And they got those mothers to teach the others, and in an amazing time, this spread over a few years, and the malnutrition problem disappeared. I won't talk so long about the other. The other one was in Egypt, with the problem of genital mutilation of young women. But they also made significant progress with that. They're retired now. They consult with U.S. corporations in the same thing. The corporations have consultants come and tell them what to do. It never reforms anything. But if they find the positive deviance within the corporation, then do this same kind of thing, then it seems to work. So I think that's maybe an approach worth serious consideration.
One should not forget also to say that compared to the situation 50 years ago or 60 years ago, it's much more difficult now for young people to enter a scientific career. The competition is higher, difficult to get position, the salaries are very low compared to what you gain if you are a business or consulting. So, you know, when you are young people, when you want to marry, to have a family, choosing a scientific career, it's more and more difficult. That's also a very important issue, not to discuss.
Este asunto salió ayer en la discusión con los estudiantes, también con los médicos. Surge siempre que se trata de este tema el asunto del tratamiento salarial y de condiciones de trabajo de los científicos y también de los profesores. Por eso yo he dicho en mi intervención al principio que para mí la solución al problema de la educación no es grandes avances metodológicos o técnicas de enseñar, sino tener gente bien formada, bien motivada, ilusionada, reconocida socialmente y bien pagada. Hombre, no es difícil, pero igual hay que avanzar. Y en este sentido, a veces, los científicos, con algunas declaraciones, no contribuyen a la causa. Por ejemplo, repetidas veces, la pasión por conocer de los científicos es tal que disfrutan de tal forma que dicen en los medios de comunicación que y encima me pagan por hacer lo que disfruto. Es un error tremendo si con eso se entiende que se acepta que les paguen poco. Porque Messi, por ejemplo, también disfruta metiendo goles, pero jamás pactará una reducción del salario. Y el señor Botín también disfruta siendo presidente del Santander, y eso no afecta a su salario. El hecho que los científicos y los profesores, con pasión y responsabilidad social, disfruten de lo que hace, no debe llevar a que sus condiciones de trabajo no sean las mejores posibles, que implique un reconocimiento social y un bienestar material para sus familias. Pues claro, si en una familia la hija más brillante se ha dedicado a biología molecular o a física cuántica y anda mal viviendo hasta los 40 años y luego sobreviviendo, eso sí, disfrutando mucho con su trabajo, y el pequeño es un broker de economía del casino que no disfruta nada con su trabajo, quizás sí, pero que vive en unas condiciones materiales, ¿cómo le vas a pedir a los sobrinos o a los nietos que elijan ciencia? Una broma, pero no tan broma.
I think you mentioned also social recognition. That's also very important. Salary is not the only thing. Social recognition is very important. I remember when I was young, the prestige of a primary school teacher, of a high school teacher was very high. Now it decreased a lot, because society gives more importance to football players and business managers. And I'm traveling a lot, and what strikes me most now is when I go to Asia, India, China, the prestige of science, of scientists, of teachers, is much, much higher. No comparison with what is considered in Europe, for example, and probably also in the United States.
Yo quisiera aprovechar para hacer una pregunta. En la tradición judía, por ejemplo, I think you are from parece que hay un gran respeto por el conocimiento, el aprendizaje, la libertad individual. Einstein tiene frases sobre eso. ¿Creéis que esta es una de las características de esta tradición cultural que ha hecho que, por ejemplo, creo que el Politécnico de Brooklyn, en Nueva York, tenga 6 premios Nobel? ¿O creéis que afecta a esa tradición y que esta es la explicación del gran éxito de esta tradición cultural en llegar a los más altos niveles de cultura, de arte y de ciencia?
I really believe that you're right. I remember in my family, the most important thing for my parents is the education of the children. And they were not very rich, but all the effort we are doing was to ensure that the children would have the best possible education.
No, there's no question. Such an attitude in a family is enormously valuable. I mentioned my family didn't have a background in education, but my parents were very, very encouraging. They were happy to see the interest of the children. 5 of the 6 children went to college. Another one is also a professor in university, 2 out of the 6, you see. It totally transformed the lives of all of us. And, so our children now, among them, there are already 6 PhDs among the family, the next generation. I think the grandkids will have some good models, I hope.
Heinrich?
Hola. Bueno, yo más bien sería igual una reflexión, ¿no? Hace unos años el lema de un congreso ponía «La ciencia es cultura». Y realmente creo que eso es lo que no hemos sabido los científicos expresar en la sociedad. Porque cuando hablamos con gente que no es científica y sale una ecuación o sale cualquier cosa, uno es culto si sabe hablar de cuadros, si sabe hablar de esculturas y demás, pero en cuanto se habla de ciencia, basta con decir, no, a mí no me digas que yo no soy científico. Parece que es una cosa que está fuera de lugar. Y la sociedad nos está vendiendo la idea de que uno es famoso si sabe salir por la tele diciendo cualquier burrada, cualquier tontería, pero no es capaz de confesar a la sociedad la ciencia que hace o cómo la hace. Entonces, si nosotros no sabemos valorarnos entre nosotros como para vender a la sociedad la importancia de la ciencia, evidentemente la ciencia nos relega, nos deja al margen. Y yo creo que por ahí es donde las vocaciones científicas se pierden, porque la ciencia lo que vende la sociedad es individuos con capacidad de frustración, individuos que no salen de su laboratorio, en el mejor de los casos, ¿no? Y si no están chalados, ¿no? La imagen típica del científico es bata y los pelos ¿no? un poco para cada uno para su lado, etcétera. Entonces, si nosotros no somos capaces de vender la importancia que tiene la ciencia a la sociedad nos va a relegar. Y como habéis dicho antes, todos cuando somos niños somos científicos, no solo en potencia, sino en esencia. Y tenemos una capacidad importante de decir, cuando yo no sé nada, lo primero que hago es preguntar, no sé, y darme cuenta que alrededor hay un montón de gente que es capaz de darme la respuesta, otros científicos. de cualquier índole. Si eso no lo valoramos, la sociedad no lo va a valorar.
Entiendo que vamos a hacer 2 o 3 preguntas al mismo tiempo y luego comentan.
Sí, vamos. A mí sí me gustaría, como en parte me tocan algunas responsabilidades políticas y como ya sé que no es la mejor época precisamente para prestigiar a los políticos esta que estamos viviendo, pero bueno, sí me gustaría plantear 2 cuestiones concretas. Una, de lo que estamos hablando del prestigio de los científicos. Y se está hablando constantemente del nivel salarial o de los ingresos que tiene un científico o incluso alguien que se dedica, digamos, a la enseñanza y al mismo tiempo a la investigación. Un matiz. Hay una parte de la ciencia que efectivamente está también muy ligada a los negocios. Digamos, yo eso lo dejo a un lado, pero de la otra parte la pregunta concreta sería, desde un punto de vista de la experiencia de su vida, ¿cuál sería el referente salarial ideal para alguien que trabaja en la investigación? ¿Sería el de un abogado, el de un médico, el de un empresario? Es decir, no hablamos de dinero exactamente, pero ¿cuál es el nivel que sería el equivalente? Porque, claro, yo dentro de la administración me encuentro con el problema de que tenemos siempre recursos escasos para todas las demandas que existen. Y la segunda pregunta. Es una hipótesis. Imaginémonos que ustedes son un reino. Hay un rey y les encarga a cada uno de ustedes por separado, tienen 100 euros y es todo lo que tienen para organizar la educación de ese país. Según su experiencia, ¿cuánto de esos 100 euros dedicarían a la enseñanza primaria, cuánto a la secundaria, cuánto a la universidad y cuánto a la investigación?
Do you want to try, Claude?
I really don't think that the motivation when you are doing science is to earn a lot of money. It's not a motivation. Motivation is passion for science. But I think we should have a decent life. And, you know, when you consider young people now, first, doing a scientific career, it's a long education. You cannot, a PhD at 26, 27, 28. And then getting a position in a research position, you get 30, 31, 32. And when you start with a salary of, I don't know, 1,700 euro, for example, in Paris, you cannot have a flat. If you want to marry and you have a family, it's difficult to live. So I don't want to earn as much as a businessman, but at least a decent life, to be able to have a house and to found a family and to live in a decent way.
I would totally agree with what Claude just said. Incidentally, I once, some years ago, wanted to find out how the salaries of high school teachers in Japan compared with the United States. It was very easy to get the information for Japan. There was the 85th percentile, that is, only 15% of the population made a larger income than high school teachers. In the United States, I had to call 7 or 8 places to get information. Best I could figure out at that time was about 50% percentile. That is, half the population earned more than the high school teachers. So we're talking sort of in those terms. I mean, it's maybe a way to think.
I don't know. Let's say I do not complain. I was.
IBM.
No. You see, IBM. I always had less salary than my colleagues who were professors at the university or at the ETH, except when I became an IBM fellow and afterwards got the Nobel Prize. Then I think that changed dramatically. But before, I had a reasonable salary. Now, it depends what criteria you want to apply. You see, what do you live off now? Everybody. I think you live of what science has done for you. There would be nothing. There would be no industry, would be absolutely nothing. You would do the same thing as people did 2,000 years ago. So from this point of view, I think science has made a tremendous, improved your life like nothing else. I think there is no way around that. Now, on the other hand, we need the doctors. We need even the lawyers, probably. That's why we have so many. But we can do without scientists for a year or 2 years, you see. It wouldn't change much if there wouldn't be any scientists around, except in the next door, they wouldn't spend money. But otherwise, scientists are not of an immediate utmost need for society. Also, society lives all in all of what science has done for society over the last 100 or 200 years. And so that's always a difficult question. If I go home late with a train and I see people coming home really worked down in the train, I always have a bad conscience about my salary compared to this guy sitting opposite me, because a lot of these people who make very low salaries do their best. And I think that's also for scientists. I think it counts whether you do your best or not. And then we have then, in addition, we have then, unfortunately, very much different criteria. That's the, how do you say, the demand and what is...
Demand and supply.
Yeah, demand and require. And I think from this point of view, I think the salary of a scientist simply reflects this demand and require.
Visto que nadie ha querido entrar en los porcentajes.
First of all, I would like to thank you all for this great opportunity. And, well, Professor Echenique has somehow introduced my question earlier. I would like to, well, emphasize the fact that the way we develop, it depends a lot on our culture and our background. So in that sense, I would like to ask all of you, because I'm pretty sure you have known all these years, very different people from very different countries and different cultures. First of all, which would you say are the virtues and the defects of a Spanish teacher and a Spanish researcher? And which country, not even university, but which country or which culture would you suggest us to visit to try to overcome these defects and to gain new skills? Thank you.
Bueno, para darles tiempo a pensar la respuesta, contestaré yo primero, ya que era dirigida a todos. Yo creo que la ciencia es internacional en sus valores, no depende de nacionalidad, raza o clase social, pero sí las condiciones en las que uno trabaja en determinados países sí que son diferentes. La universidad, por ejemplo, por centrarnos, es la institución que ha sobrevivido a más cambios probablemente en Europa, después naturalmente de la Iglesia Católica, porque ya lleva 200 años y ha ido ensayando formas de ensayo y error, autorregulándose. Y yo creo que el producto más sofisticado de esta evolución son las universidades de investigación norteamericanas, las grandes universidades norteamericanas, en que hay, en realidad, en palabras de Rumsfeld, el secretario de Defensa, refiriéndose a la vieja Europa, yo cuando visito a Dudley en Harvard tengo la impresión de que Harvard es el sitio donde mejor se defienden los valores de la vieja Europa, en el sentido de respeto a la libertad de creación, poca carga docente, pensamiento, atracción, universalidad, la educación liberal, enseñar a pensar, a formularse cuestiones etc. Pero claro, esto se consigue con un sistema que en Europa es prácticamente imposible por la burocracia, y lo tienen 100 universidades americanas. Hay 4.000 universidades en América. Dígame usted dónde están las 100 mejores universidades del mundo, le preguntaron a Harriman. No lo sé, contestó. Muchas son americanas. Ahora bien, las 100 peores, todas son americanas. Eso quiere decir diversidad y heterogeneidad de las instituciones. El sistema europeo, muy concretamente nuestro, sobreregulado en mi opinión, quiere que todos sean igualmente buenos. Y el resultado es que todos son igualmente medios. Creo yo. Entonces, obviamente, hay excepciones. Yo, si tuviese que elegir otras excepciones, el College de France es una excepción, las grandes escuelas, Oxford y Cambridge, y particularmente algunas de las grandes universidades suizas, una donde estudió la Heinrich, ETH. Por cierto, ahí los profesores suizos, yo diría que un profesor suizo en términos relativos es lo mejor de Europa. No hay más que ver el número de profesores alemanes que tienen las universidades suizas. Pero eso es una broma. Lo que quiero decir es que no hay recetas generales, las personas son todas igualmente capaces, pero hay tradiciones culturales, en mi opinión, la que ha citado Cohen, que da mucha importancia a los valores de la educación, etcétera. Obviamente no es exclusivo de ellos. Dudley viene de otra tradición y tuvieron los mismos valores, y probablemente Heinrich, que sí que fomentan esto. Si yo tuviese que elegir el sistema que a mí me gusta, lo que pasa es que es el sistema de las universidades americanas. Lo que pasa es que eso tiene que ir acompañado de otros valores. Y en América, no en las universidades, no se cuida, en mi opinión, suficientemente al que se queda atrás. Y estos valores de solidaridad social que Europa tiene, no hay nada, no podemos perderlos. ¿Cómo conjugaríamos el respeto y la protección al que se queda atrás, que es algo de lo cual los europeos debemos estar orgullosos, con la competitividad americana? Y yo siempre digo que podemos ganarles a los americanos, pero si aprendemos de los americanos. Y hoy en ciencia, lo dijo el día pasado Lord Patten en un artículo, Europa invierte menos y tiene una arquitectura institucional más rígida, más burocrática, lo cual hace que la ciencia de frontera, en términos relativos, se haga más en los Estados Unidos. Europa tiene una dificultad añadida. Los americanos pueden concentrar todo su esfuerzo por la multinacionalidad y la interculturalidad en 200 universidades, pero ¿qué país europeo aceptaría que las grandes universidades europeas fuesen Oxford, Cambridge, París, Zúrich y Berlín? ¿Aceptaría Italia esto? Quiero decir que la estructura nacional también, que tiene muchas ventajas, porque todos, yo suelo decir que hay que abiertos al mundo, pero sin olvidar las raíces. Nosotros tenemos aquí pues todo nuestro idioma, el euskera, un montón de cosas que hay que preservar, pero que añade dificultades a una competitividad extrema. Entonces, para resumir una respuesta demasiado larga, yo pido perdón a los tres ponentes porque les he dicho que deben responder corto y yo me he alargado mucho. La única excusa que tengo es que consistencia es una virtud de pequeñas mentes y siento haber sido poco consistente.
You have not to worry. You have made a very nice speech. I think you summarized everything very perfectly. I don't think they're the perfect institution. You have to be inspired by what is good in the various institutions, the American system and the European system. I think in Europe we have also the possibility, a very great possibility, which it is clear in science, a mobility between the different European countries. I think that Europe is difficult to organize, politically difficult, but scientifically there is already a united Europe. Because, for example, in my lab, more than half of the people are coming from Germany, Spain, Italy, Sweden. The mobility of researchers among Europe is really a reality. there are very good institutions like CERN, which is a fantastic institution in particle physics, which is a big success. So I think we have good challenge in Europe to be pursued. And of course, have a lot of constraint due to the nationality, to the difficulty, but I think the situation could be very good.
De hecho, es la razón por la que creamos el Donostia International Physics Center, para internacionalizar más la ciencia. Y en estos 10 años, 1.200 investigadores de Europa y América, algunos japoneses pero menos, han visitado nuestro centro en estancias superiores a un mes. Nuestro centro en este momento, entre postdocs y así, hay personas de 17 nacionalidades. Somos pequeños, con la humildad del pequeño. Euskaraz esaten da, alertxuntek esaten zuena, ez haundiaren arrokeriarekin, baizik txikiaren arrotasunaz. Estamos muy satisfechos de lo que hemos logrado. Perdón otra vez por la intervención.
I just comment. I like very much both of the most recent answers, yours and Claude's, so I needn't add to that. I have noticed very much we could call internationalization of European science. I mean, every meeting, and you see lots of joint papers, people from different countries. The EU kind of attitude is, I think, enormously valuable and become more and more obvious as time goes on. That is a great strength of European science.
I think the fact that I live in Switzerland shows that I prefer Switzerland for some reason. Now, if I, beyond just the scientific aspect, if I would have to live in Spain for whatever reason, I think I could make a very good living for myself. Whether it would be the United States. Okay, probably I would choose certain places in the United States. But if I would have to live abroad, most of the countries wouldn't be a horror for me. I would make my living the way I can make it in these countries. I think that's important also for the young people, you see. It's not just what you want to do. It's important that you can arrange your life according to what you have to do and according to your possibilities. I think that's something very important. And the second important aspect is you should not only do what you like to do. You have to make efforts. You have to work hard. You have to make efforts. There is no way around that. And I mean, you remember it with the Boy Scouts or me in the Swiss Army or whatever it is. The best, let's say, when you talk about something and when you are proud, that's when you have overcome some efforts. You see, when you had to have to really invest a lot of effort to overcome something. And I think that's for science, it's exactly the same. For having a scientific career. Of course, you choose things a little bit to your ability, but it's not only the ability. You have to make your efforts, and once you have chosen, you have to stick with your decision and make the best out of it.
Quisiera saber en sus carreras científicas cómo han tratado el tema de la propiedad intelectual y las patentes. ¿Qué opinan de este tema en la ciencia? ¿Cómo funciona o si cambiarían algo?
Since I worked for a company, I think I was confronted always with this issue. And I have an understanding for intellectual property. It's a property just like everything else. But I think in this respect I was with a very wise company. IBM licensed its patents to everybody who wants to license them. They have never had any exclusive license practice. And the license fees are ridiculous, very low. So from this point of view, I think that's big. IBM realized that a patent is important, but patent very often slow down the progress, the general progress. Take, for instance, copying. As long as Xerox had the copyright, had the patent rights, copying was a modest business. When this was finished, that business went shooting up like crazy. Take fax. Fax never had a real patent on the principle of fax. And that's once fax was introduced, it just blew up very fast. Same thing is with email, with the net and so on. So patent might be necessary for enterprises to protect a little bit their investments and also to create money for new investments. But we always have to realize that patents also can slow down the progress in general.
No, I don't think it's necessary.
Puesto que el doctor Rohrer procede de la empresa, de una compañía, dice que usted trabaja en una compañía, y yo querría volver de nuevo al tema que se ha planteado anteriormente de las vocaciones, de las crisis de las vocaciones en la juventud. Es evidente que un joven de hoy no es igual que el de antes. Pienso que la gente quiere cuanto antes terminar, ganar dinero, tener un coche y resolver su vida rápido. Las carreras de medio a largo plazo no interesan. Pero está muy relacionado, pienso yo, con el mercado de trabajo. Y aquí al final lo que subyace es que toda la investigación es institucional o pública. ¿Cómo hacemos para que la empresa demande más y esté convencida de que la investigación es su futuro?
I cannot talk of experience. I think IBM realized that research is their future. And I think that's quite a lot of companies realize that. Smaller companies might not be able to have their own research efforts. But there it's a little bit like with farmers, you see. Farmers didn't realize that they have to have that they have to get together. And maybe only 5 farmers together can really afford a very expensive machine. They have to have, each one has to have his own expensive machine and gets the, the state support for it. Now with small companies, I think they have not understood yet that they have to team up to certain units which might do some research together. It can be a very loose organization. It doesn't have to be something. And it's, for me, the problem is simply the understanding of the various companies.
I certainly hear a lot about the importance of science as an innovative kind of factor in the economy. I mean, I know many countries are emphasizing science education for just that reason. For instance, Jordan has no natural resources. The median age of their population is 18. That's incidentally pretty much true, except for the research aspect, but the median age, I mean, among all the Arab nations. They're very concerned about developing an economy that will give jobs that are interesting for those young people, or they will not have a stable country. It's clear. So it's a very important thing, and I don't know how it will become more broadly appreciated where it needs to be, except if it's spread, the message continues to be spread and amplified in the media.
I have two questions. First question, I think that European companies do not invest enough in research. It's difficult for a company having a stock market shares. It's better to try to speculate in the stock exchange than to have a laboratory with research and so on. And most of them are exporting their research center. That's the first question. I think there's some mentality to change, because the managers should understand that in the long term, it's very fruitful for the companies to have a research activity. That's very important. For example, the example of Bell Labs was fantastic. Bell Labs they had a lot of research team. It was free to do what they wanted, and they had, I don't know how many Nobel laureates came from the Bell Labs. And then they cut it. They cut it because, okay, that's the first question. Second question, I think you mentioned Jordan country. I think one of the most important problems of this century is how to reduce the gap between developing countries, having Europe, United States, having some research activity, some economic activity based on research, and the developing world, Africa and things like that. I think the gap is increasing, it's not decreasing. And that's a very, very, very difficult problem. And I think that one should think, scientists, we should have the responsibility to try to help developing countries to build programs, scientific programs, and to develop higher education. Yeah. I think that's a crucial problem. If we don't do that, obviously we'll have more and more pressure from this country to immigrate, and we'll have a very serious problem. Also, that would be a very good ground for development of fanatism and things like that.
Okay. Si hay una última pregunta.
Sí, hola. A ver, yo hablo desde el punto de vista de un científico. Se dice que hay que ver que como somos los científicos, que esa imagen del científico 100% en el laboratorio, esa idea de que el científico no quiere salir del laboratorio para divulgar. Y yo creo que hay un problema de base y que creo que aquí pediría un poquito de comprensión a los profesionales que no son científicos, que es el problema de la valoración de nuestro currículum. Nuestro currículum se valora, diría que al 100%, por los artículos científicos que tenemos. Y bueno, el tener un artículo más o menos en una determinada revista o en otra puede suponer el acceder a una posición estable o no, o por ejemplo a muchos colegas míos españoles que están por el mundo, el volver a España o no a reunirse con su familia. Yo conozco pues eso, muchos amigos que tienen a la mujer o a los hijos aquí, ellos están en Estados Unidos, están en Reino Unido y no pueden volver porque no tienen un determinado artículo. Entonces yo pienso, y quiero saber si estáis de acuerdo, yo pienso que habría que valorarse un currículum más multidisciplinar y que también incluyera cosas como la participación en actividades como estas, ¿no? En divulgación. Y si estáis de acuerdo con que esto se tendría que hacer, ¿a quién habría que convencer para cambiar el sistema de valoración del currículum profesional de un científico o por dónde habría que empezar? Gracias.
You already answered.
Of course, you're perfectly right. That's a very important issue of the brain drain, how to get the people having spent some time abroad to come back. I think the question is twofold. First, we should find solution for offering them attractive position in the initial country to stimulate them to come back. That I think is a very important question. And for example, let me take a completely different example. China. A lot of Chinese scientists were in the United States, and they decided politically really to change completely the situation, and now they offer very high salary, very good working condition, and a lot of Chinese scientists are coming back. So, you know, that's a political will, and they want to change the situation. Also, the second point is you have to develop in the country attractive centers, able to attract people to come back. It's not sufficient to have people coming back if you are not offering them stimulating places where to work. That's the second point. You should be careful to develop enough scientific centers in the country to be able to attract people back.
I also was confronted with this question when I was on the board of the Institute of Technologies. And there is always one problem. I think, you see, good scientists always find a reasonable job. Nearly always, not always. But you see, just the fact that somebody spends a couple of years abroad doesn't make him a first-class scientist. It might not. And what do we then do? I think the problem of sending people abroad, we have to carefully select the ones we send. Not select them before when they come back. I think the selection already has to be done carefully when they leave the country, and then we have less of the problem. Now, that's also in science. Of course, we can produce more and more scientists, but I think it requires a certain standard. And simply to increase the number of scientists is not worth much. We have to be able to increase the number of good scientists, and I don't know any way to do that. But that's what we have to have in our head.
The key thing, as you mentioned, is how the young people are assessed in terms of their total activities, total contributions. And that's, I think, apparently sort of a cultural change that has to be made. At the moment, bureaucracy is dominant, and there's an automatic kind of counting system or whatever that looms very large. Again, I don't know enough about how to deal with that kind of world. I always come back to saying that if you can make people enough aware of stories that convey a strong message, like I'm quite sure Einstein would not do well on such a thing. The thing I remarked earlier that Sommerfeld said in quantum statistical mechanics, you want to weigh, not count, and so on. In fact, Einstein, in talking about voting, made a famous statement that, some things can be counted but don't count, and vice versa, something to that effect. And so there's no substitute for a system that puts people of judgment and vision in a place where they can influence a structure that, and also they have to, everybody has to come to appreciate how important it is for the future. It's the young generation that really matters for what's going to happen to the country and the world, for that matter. So it's It's a major thing that most of us, I think, don't know too much how to cope with. If a positive deviance can be found, I think that's one significant way, because as I mentioned in the story earlier, from these people I know very well from Save the Children, they have coped with some very tough problems and found that method was the one that could work. I don't know enough to know how many positive deviants. You could say DIPC is a spectacular positive deviant.
We have many good centers, not as good as we wish.
Thank you.
Many others. There are several universities in our country, and they are good centers. And the University of Navarra is here, University of the Basque Country, the University of Mondragon. In all places, they are good people. But anyway, I think we must go for lunch, because there's a rule of these encounters that we finish at 1:30. It's also another rule that the moderator summarizes the debate, but it has been so rich and so deep and so full of good ideas that, of course, I am not equipped intellectually to summarize all the beautiful things that have been said. Let me only quote 3 or 4 about the business people. $2 out of $3 in America are put in America for research are put by companies, and 3 out of 4 are spending companies, even more, because they use public money. This is a tradition that, as Claude said, we don't have in Europe at that level. I mean, for whatever reasons, I don't think the companies will invest in research with a long-term vision unless they see the necessity. Necessity is the mother of all investments and mothers of all inventions in these fields, I think. And I think the crisis has changed this view. As Heinrich has told us about Switzerland, I think... estoy hablando en inglés, pero paso a castellano, que es más relajado. No hablo tan bien euskera como algunos de los que están aquí y estoy muy cansado, sino también lo haría en euskera. La crisis ha cambiado. Yo creo que en Estados Unidos hay un crecimiento de las inscripciones en programas de doctorado. En nuestra facultad, la Facultad de Químicas de la Universidad del País Vasco, Euskal Herriko Unibertsitatea, es el buque insignia de investigación básica de toda la Universidad del País Vasco. Tenía poquísimos estudiantes hasta hace 3 años, algunas han estudiado aquí de profesoras que veo. Este año ha crecido sorprendentemente. Yo creo que hay un cambio, no sé si esa es la razón en Suiza, pero el cambio de vocaciones, de inscripción, ¿no?, de vocaciones científicas, porque la de matriculación en las facultades de ciencias ha cambiado y la pendiente es positiva en los 2 últimos años. Hemos visto la enorme importancia que nuestros ponentes dan a la internacionalización. Hay que salir, pero también hay que crear las condiciones para que luego se pueda volver en buenas condiciones profesionales, ¿no? Hemos oído la elegante frase de Dudley, que la ciencia no es un conjunto congelado de dogmas, sino una aventura intelectual, una aventura humana, motivada por la pasión por conocer, ratificada por Heinrich, lo cual exige que el sistema educativo, aunque no pueda crear creatividad en los niños, por lo menos no apague la creatividad innata. Se ha mostrado por los 3 ponentes una actitud absolutamente casi renacentista, de visión global de la cultura, no solo con lo que ello se llama ciencia, sino con lo que alguien llama humanidades, que en realidad la ciencia también es parte del humanismo moderno, pero ellos han tenido una visión global y le han dado mucha importancia. La ciencia es parte esencial de la cultura moderna y en los últimos años ha cambiado, han dicho Heinrich y Dudley y Claude, la concepción del mundo en que vivimos y de nosotros mismos. Es decir, el edificio conceptual de la ciencia moderna quizás es la obra colectiva cultural más importante de la humanidad. Incluso la obra de arte colectiva más importante de la humanidad. ha mostrado como el valor al soldado, que los científicos tienen que ser éticos en su comportamiento y con visiones éticas. Me ha recordado una frase que le oí a alguien, creo que era Lain Entralgo. Él hablaba de humanidades separado de la ciencia, que sin ciencias blandas, las ciencias duras muchas veces no son humanamente suficientes. Pero aquí la necesidad de que las ciencias duras también estén en los currículos ha sido enfatizada por los ponentes, y yo completaría esa frase que sin ciencias blandas las ciencias duras no son humanamente suficientes, pero a veces sin ciencias duras las ciencias blandas no son intelectualmente suficientes. Esa tradición cultural que han preguntado afecta a la forma de hacer las cosas, y es verdad. Yo les voy a dar un dato. Dudley sabe muy bien, porque es su mujer Georgine, una mujer maravillosa que está con nosotros y que también irá a la excursión a Elizondo. Vamos a ir en bici, vamos a ir de aquí a Elizondo en bici con Dudley y vamos a comer en uno de los valles más bonitos del País Vasco, que es el Valle del Baztán, en Navarra. Entiendo que esta frase puede producir una conmoción política si la dijese en Pamplona, pero la Universidad de Harvard, por ejemplo, en que su mujer ha sido decana de artes del college, tiene un endowment, un fondo de reserva, de cuyos intereses se nutre su presupuesto, o tenía en 2007, antes de la crisis, de 38.000 millones de dólares. Para que ustedes vean con quién competimos en Europa. Estos son datos muy importantes. Uno de los grandes objetivos que yo tengo en el DIPC es crear un endowment. O sea, si conocen amigos ricos, comprendo que la Universidad de Navarra tendrá otros objetivos, pero los demás dejen la herencia al DIPC. En resumen, yo dije en la inauguración de estas jornadas maravillosas que están yendo cada charla. Son charlas espectaculares que nos emocionan, y esta tarde tenemos 4 ponentes de excepción. Recomiendo que vayan, pero el resumen de lo que les hemos oído yo lo haría de esta forma. Transmitir que la ciencia, y para atraer a la gente, la mejor forma es transmitir que la ciencia es una actividad estéticamente hermosa, la estética, culturalmente importante y económicamente decisiva. Y a esto es lo que pueden contribuir ustedes, y nosotros les estaremos muy agradecidos. Nos han ayudado mucho los profesores al Donostia International Physics Center y a nuestros grupos de investigación. Nosotros vamos a ayudarle lo que podamos, y una vez que nos recuperemos de estas jornadas, porque la pasión siempre tiene que decaer un poco para volver a surgir, estaremos en contacto otra vez, y muchas gracias. Eskerrik asko.